Are we here? Yeah. Nice. Now, you guys don't have to answer this accurately or at all if you don't want, but are we all awake? Yes. Good to hear, good to hear. Welcome one, welcome all to DConf 2023 in London again. Woo! Yeah. There we go, that's the programmer energy we all know. All right, so here's a little bit of a trivia for you all. The first DConf was in 2013. That was about 10 years ago. We've been doing this for that long. Wow, and we're still going. And you're not sick of it yet. Excellent, keep coming, keep coming. It's great. Now, you might notice we're in the same venue as last year, so that means speakers be aware, do not perform the Ali maneuver mid-talk. You're going to want to stay on the stage here. It's just better for everybody there. Yeah. Okay, what else have we got? Name badges. I have been informed that our name badges are recyclable this year, so you can put them in the what do we have to do? Hand them to the staff at the end, put them in the bin or something? Yeah, something like that. Hand them to the staff, and then they can deal with the recycling. The other thing with the name badges, a lot of us know each other by our online handles, so if you've got a Sharpie, just stick your name on the bottom of them. I've put my name, Gooberman, down there, so there we go. What else have we got here? Fire safety, fire safety. So, in case of fire, hopefully that we have not started ourselves. No, that would be bad. So the fire alarm is going to be pretty noticeable. You're going to hear it. It's going to make you get out of the building. But what you should do is step one, remain where you are. And then wait for the next bit, which is the venue team will say, now you've got to leave. And when you leave, it's straight out that door and then to the right, down to Finsbury Circus Bandstand. It's just on the corner down there. And yeah, that's the fire drill done. And, where'd it go? There we go. Oh, that's all we had to do for the intro. So how are we all feeling? Cool. Ready for a full 3 days of talks? Yep, there's that programmer enthusiasm again. Brilliant, brilliant. All right, I'll leave you all alone. Let's just get going then. We have Saeed down the front here who's going to talk to us about, I've lost the page, sorry. Well, you can intro us yourself. How about that? Come on up stage, man. And, come on, programmer energy.
Thank you so much. Wonderful. Good morning, everyone. It's great to see you all. I'd like to express my gratitude to all of you for attending this event. And I'd like to extend my special thank you to Walter and Michael for granting me the privilege to speak at the DConf this year, which I really hope is not the last. Let's see how it goes. Another special thanks to Walter for surrendering his opening spot. I was originally scheduled to speak on Thursday, which put me closer to the IB workshops that we're going to have on Friday. But on reflection, we thought there might be a lot of questions about IB for me. And based on Attila's experience last year, it's better for me to speak today so I don't have to spend 2 days saying, please wait for my talk. My name is Saeed, and as you see, the title of the speech is The Truth About D. But you also see there's a subtitle there that says, A Surprising Way to Increase the Popularity of D Language. To be honest, the subtitle was originally the main title, but Walter forced me to use that title, so now I have two things to talk about. Thanks, Walter. They're the same thing. All right, but before I start, since this is the first talk, by show of hands, how many of you really know each other well? You really, is there anyone new here, like completely new? First time? Okay, wonderful. All right, I have this very, very small activity we want to do. It's just fun to wake us up a little bit. 4 minutes. And I want you to turn to somebody next to you, behind you, in front of you. Just find one person and introduce yourself and answer this question. What is the most transformational story of your life? I'm going to give you 4 minutes, and make sure everybody speaks for 2 minutes, so give time to somebody else too, all right? I'll let you know when the 4 minutes is up. Go. Two minutes. Two minutes. Two minutes left. Switch. Thank you. Thank you. Wonderful. How many of you heard something new about someone you already knew? Ah, nice. Oh, lots of transformational stories. All right, wonderful. Thank you. At the core of my speech today, I'm going to talk about transformation. Transformation on both individual and organizational level. But before we start, I would like to raise a few questions in your mind. The first thing you should know about me is that I'm not a programmer, and I don't know anything about programming languages. I mean, having been working for a technology company for years, I've heard a word or two. Words like ifs, ands, library, and compiler. but that's as far as my knowledge goes about the programming languages. So there might be a question in your mind. So what does someone who doesn't know anything about programming languages have to say at DConf, a conference that is dedicated to a programming language? Believe me, I asked the same question of myself the day that I was invited to speak at the DConf. But then I realized that's a good thing, because I'm going to talk about D language from a completely different perspective, a perspective that you may not have considered before. The second thing you should know about me is that I'm the Director of Organizational Development at Eucora. This is also known as the Chief Ivy Officer. That raises three questions. What is Ivy? Who is Eucora? And what does all of this have to do with the D Language Foundation? But my story with D first. The first time I heard about D was the first time that I actually joined the Eucora team. I vividly remember that because they wouldn't stop talking about D. And they told me how important D language was to them and to the whole business. Since I was not a programmer, I really didn't know what the fuss was about. So I let it go. A couple of years later, when we were looking for an experienced programmer, I introduced somebody to the team. And after the initial talk, that person was quite surprised that Eucora had chosen D as a programming language for the softwares they were developing. He kind of judged Eucora for choosing a language that, in his words, no other programmer has heard about. He was concerned about his future. He said, what's the point of learning a language if I'm not going to use it in any other organization after Eucora? Well, valid points. That always stuck with me. He did join us and our team, and a year later, he realized why Eucora chose D. Fast forward 2022, 2023, when we reached out to the D Language Foundation to offer our support. And we started our Ivy organizational development workshops with them. And throughout the workshops, I could see how the DLF team was so passionate and enthusiastic about this language. They would tell me wonderful stories and how it's different from other programming languages. That's something interesting about D. When you speak to programmers who do know D language, they often tell you magical stories. Here's one of those stories. I talked to the founders of this technology company a while ago, and they told me how they got to choose the D language for their software. This company had gone through lots of ups and downs and had survived events like .com crash and 9/11 era, when most organizations were forced to lay off their entire team. But after the economy rebounded, they made a decision to make some radical changes to their business. One of the changes was shifting from an hourly service model to a software as a service model. And as the nature of the software as a service model required, they had this all-inclusive arrangement with their customers. What that meant was any system additions, system changes, meetings, phone calls would not result in fee increases. So they were compelled to increase the quality and reliability of their software while reducing the programming time and minimizing rework and bugs. But they had a big challenge. And the challenge was the programming languages they were using at the time would not allow for that to happen. Frustrated with all the overhead costs and time wasted on programming languages such as PHP and C++, they decided to dedicate a significant time of the company to researching on a more appropriate programming language replacement for their platform that they were trying to build. After careful consideration, they chose the D programming language. When we got to this part of the story, they told me something really interesting, and I'm quoting. It was a miracle that we found D. We don't know where we would be if we hadn't. The D language enabled us to free up time and resources to think and innovate. To think and innovate. Quite impressive. By the way, this story is the story of Eucora. And the people who said that are Paul and Robert Toth, who are sitting in the conference today with us. In fact, with the support of Government of Canada's Scientific Research and Experimental Development, we are working on a unique clustered computing environment combined with an AI-compatible database structure, completely written in D. I really hope that during the conference you find the time to speak with Paul and Robert about their experience with D language. But when I got invited to speak at the DConf, I was so motivated to answer this question in my mind. How can D be propelled into the ranks of the most popular languages in the world? And the answer to this question is this. My intention of telling you the stories of transformation today is to talk about how the true value inherent in DLF goes beyond the language itself, and how this will unlock DLF's future. Now, to map this journey out, I will tell you 3 stories of transformation. Story of Eucora's transformation and how it's related to the D Language Foundation. Story of individuals' transformation, because organizations are nothing but people. And 3, the story of DLF's transformation, which has already begun. Eucora is a Canadian company that has been delivering information system and organization development services for over 3 decades, with customers across Canada, the United States, and internationally. Our clients range from small organizations to large Tier 1 firms, such as AXA Insurance, Ryan LLC, Deloitte, and since we're in the UK, and T is a big deal, even the Tetley T team. We developed our Surveys 1.0 workflow platform, and then its subsequent version, Surveys 2.0, about 20 years ago. And many of these systems continue to operate flawlessly, with numerous installations implemented over 10 to 20 years ago. In 2014, we developed our new proprietary custom workflow platform infrastructure called Fractivo, which serves as the backbone for our workflow platform GamePlan Pro. And since its launch in 2014, it has been operating extraordinarily well as a mission-critical service for our customers. Now, when we look back at Eucora's and what we have accomplished, it's quite impressive for us. But this is only our resume. Let me tell you what I mean by that. During the pandemic, most organizations on the planet struggled with this phenomenon known as the Great Resignation. The idea was that most people in their organization would just leave the company, never to come back. Not knowing what to do with this problem, it led to a bigger challenge these days, the new phenomenon that is called quiet quitting. What that means is people go to work, they have a smile on their face, but inside they feel miserable, frustrated, they hate their jobs. And as they're working for this organization, they're looking for opportunity elsewhere. In order to tackle this issue, a lot of companies have been trying to optimize this hiring process. But it's not going to work because making a broken system more efficient and effective is not going to change anything. One of the broken things about this system is the resume reviews, right? They get piles of resume, go through the resumes one by one, choose a couple of them, have some interviews, and then 3 months later with 3 or 4 different interviews, they hire somebody until to find that somewhere between 35 to 40% of these people leave within the first 3 to 6 months. So what is the problem with the resume? The problem with the resume is that resume is people's past, not their future. Of course, a company needs to know whether somebody has the knowledge and the skill to do the job. But technically speaking, organizations are investing in people's past, not their future. This is the same story with Eucora. All the things that we have accomplished, we might be really proud, and we are really proud of the things that we have accomplished. We even drink to our accomplishments. Well, I don't drink, tea and orange juice and stuff. But we do drink to our accomplishments. But what inspires us is our future. And not just any kind of future, a grand future, right? An ideal vision of who we can become and who we want to become in the future. So despite our accomplishment, we could see that a bigger transformation was coming. Our Game Plan Pro platform had a few key features that gave us invaluable insights into the motivation and psychology of business owners, managers, and employees. Our all-inclusive contracts, our all-inclusive arrangements gave us the opportunity to open doors for us to actively participate in boardroom discussions. Which gave us access to the mindsets of hundreds of managers and frontline workers. With all that insight, we realized that our technical success alone did not align with our broader aspirations. We had bigger visions in mind. We aspired to transition Eucora from being a solid yet relatively small organization and propel it into a global force for change. We realized that we were acquiring a deep understanding of the significance of worker motivation, what it entailed, and why it thrived in some companies but not in others. So, with all the insight that we gained, we realized that we wanted to transition Eucora to a global force for change. But the question was, how will we go global? We discovered that we were facing a challenge, and the challenge was that we were focused on the wrong area. We were so focused on the technical aspect of what we were doing that we had completely forgotten about the core value that Eucora had to offer to the world. We realized that our core value extended beyond our software. What set our software apart was not only the technical aspect of it, it was the mindset and the underlying principle behind the software that made all the difference for our customers, that made them successful in what they were doing. Think of an iceberg. What is visible from an iceberg is just the tip of the iceberg, right? Hence the expression, just the tip of the iceberg. Because the tip of the iceberg is not a good judgment of what's beneath that. For Eucora, the tip of the iceberg that was tangible and visible was the software. So we had to go really deep to understand what's beneath the surface. After an extensive retroactive study of our entire customer base, we realized that our fundamental value was our unique understanding of worker motivation and how that could reshape organizations' operating mindsets. So we created an organizational development model that we call Ivy. And then we started implementing it through our consulting side of the business. From that point forward, our focus became transforming the world by teaching this mindset behind our software, by teaching everybody about this methodology. So we decided to change the way the world works. This new vision changed everything for our company. It reinvigorated our existing team. It allowed us to attract new and highly motivated employees. We started acquiring customers well outside our traditional customer base. And we started positively influencing lives, both on personal and professional level. So with that in mind, we committed ourselves to establishing the educational arm within Eucora dedicated to enabling everybody to understand this Ivy methodology. With that commitment, we developed our Ivy mobile application and Ivy motivational health network, both developed in D. Eucora ceased being merely a software company. We are transforming into a motivational health and productivity enterprise. The second story of transformation, individuals. Why is that important? An organization is really nothing but the group of people, collective people, who are moving towards an agreed upon direction. If the individuals within organizations don't transform, the organization will not transform. That's why the second story is important. I would like to tell you a story of someone that I worked with a while ago. Let's call him Sean. Sean is in his early 40s, and he lives with his wife and 2 kids in central Toronto in Canada. He works for a consulting firm as a business consultant, and he's really good at what he does. But there's something interesting about Sean. He has changed 4 jobs within the last 5 years. One day he goes to his wife and says, "This company I'm working with, they don't give me that motivation and excitement and fulfillment that I've been looking for. I'm really miserable, I'm frustrated, I really think that I need to find some other job elsewhere." Frustrated with this pattern of Sean, his wife replies, "I'm really sick and tired of you constantly complaining about your job. You think going from one company to another company is going to solve anything? That's not going to happen. The next company is just going to be like the other 5 companies, 4 companies. You either find something for this as a problem that you have, or this is not going to work anymore." What did Sean lack and didn't understand that put him and caused him this predicament, even with his personal relationship? To answer this question, let's do a mental exercise. Imagine that you had a magical toolbox, a toolbox that you could find anything you wanted in it, a hammer, screwdriver, you name it. Suppose I come to you and say, "Can you please make me something?" Which tool would you use? The first question that you might ask, actually, that's the fundamental question, is, what am I making for you? Because knowing what you're making determines what tools you want to use. That's exactly what happens in our lives as well. Oftentimes, we get so fixated on gathering tools in our toolbox, like education, skill, knowledge, jobs, that we forget to stop to ask ourselves, what am I making of myself? This fundamental question. Back to Sean. What Sean missed and lacked was the answer to this question. He didn't stop to ask himself, what am I making of myself? Therefore, what kind of a job as a tool is going to help me get there? He mistakenly thought that there was this job out there in some company that would give him that excitement and motivation that he's been looking for. This is where IVY comes in. IVY stands for Ideal Vision of Yourself. It's that ideal vision of who you want to become in the future. The person you're most proud of, you respect the most, you love the most. And it's an ideal vision. Why? Think of it this way. If I told you that anything you ever wanted in your life, I could make it happen right now, right here. Being a car, a vacation, a partner, what kind of a car, vacation, or partner would you choose? Probably the best of the best. Why? Because you're inspired by greatness. People are not inspired by tiny things. So you probably want to have the best car, or the best vacation, or the best kind of a partner you can imagine. That's why it's so important to think about an ideal vision of who you want to become in the future, that inspires you to move forward against all odds. But what's important about IVY is we need to kind of make it more tangible. So it's not just something in our head. So we can articulate it and also share it with other people so they can also know where we are moving towards to help us. Therefore, we have something we call IVY statements. An IVY statement consists of 3 parts that answer to 3 important questions. Question 1, who? Who do you want to become? And that statement begins with to become. Question 2 is, how do you want to move towards that person? It starts with by. Third question, why do you want to be that person? And it starts with so that I. You put these 3 together, and you have your IVY statement. Let me show you an example of an Ivy statement. To become a captivating storyteller of life-altering ideas by actively engaging in activities such as teaching, speaking, and acting, so that I have an impactful, positive role in changing the way the world works. As you might imagine, this is my Ivy statement, actually. Now, with this Ivy statement, I exactly know where I'm moving towards in my life. So when an opportunity comes in, and it's helping me move towards that, then I'll take it. But if it's not moving me towards that, I can drop it. It's just a distraction. So it makes it easier for me to make important decisions in my life. Also, I can share it with other people. So they also know, especially in my organization, right? So everybody knows where I'm moving towards, so they can also help me. In fact, this is exactly how I got invited to DConf. It was during one of the workshops with the DLF team that we were talking about Ivy statement, and they were trying to write their own Ivy statements. Then they asked me to share my Ivy statement, and I did. And that started an interesting conversation. They asked me a few questions about my Ivy statement. And then Mike said, well, it seems like based on your Ivy statement, giving a speech would be aligned with who you want to become. And I said, yes. And then he said, would you like to be a keynote speaker at the DConf this year? To which I believe I said, hell yes, if I'm not mistaken. That's an opportunity. So sharing, if I hadn't shared my Ivy statement, this might not have ever happened, and this opportunity would not have happened for me to deliver this message. Now, once you have an Ivy statement, once people get together, individuals with their own Ivy moving towards who they want to become, they make collective teams, and they become organizations. Ivy also applies within organizations. In fact, organizations have their own Ivy statements. Why? Because organizations also want to become something. And then collective of people decide what that is. Once an organization knows where it's moving towards, it makes it very clear to articulate it to the world and to everybody else. This is where we are moving towards, and this is who we want to become. A wonderful way of illustrating this point is in the story of Alice in Wonderland. If you remember, when Alice goes to the forest, she feels lost at first. She's walking around, she doesn't know where she's going. And then she sees this cat. And this is the dialogue that happens between them. Would you tell me, please, which way I ought to walk from here? Said Alice. That depends a good deal on where you want to go to, said the cat. I don't much care where, said Alice. Then it doesn't matter which way you walk, said the cat. This beautifully illustrates the fact that if we don't know where we are moving towards, then it doesn't matter where we go. In other words, if we don't know where we are moving towards, we're not moving towards anything. Stephen Covey, in his famous book, The 7 Habits of Highly Effective People, also has an interesting story. He talks about the story of a group of workers who go to a forest to cut trees. They have this manager who makes sure that everybody has all the tools they need, and then puts them into teams and asks them to start cutting trees, and they do. But one of the workers climbs up the tallest tree in the forest and looks around really carefully and then shouts down, "Wrong forest!" If an organization doesn't know where it's moving towards, how can it know whether it's in the right or wrong forest? All they know, they're cutting trees, for sure. But are they cutting the right trees? Maybe not. They might be engaged in the activities that they're doing, but is it taking them somewhere? Are they accomplishing what they need to? Maybe not. So once the organization knows where it's moving towards, and it has established that vision, then it's time for them to align everybody within the organization, all the stakeholders. Think of it this way. When you get on a bus, you see other passengers on the bus as well. You may not be sharing the same destination with people on the bus, but as long as you are on the bus, you are sharing the same direction. An organization is like a bus. This is what we call Ivy alignment. Ivy alignment means finding people whose Ivy is moving them towards the same direction, even for a short period of time. Why? Because when that happens, that means that an organization is providing the opportunity and the environment for people to move towards who they want to become, which inspires them and motivates them, and for people who helping the organization move towards what it wants to become. It's a win-win situation. The third story of transformation, DLF's transformation. Remember the iceberg? What's visible and tangible for DLF as the tip of the iceberg is the language itself. But there is something much deeper than that. When you go deep enough, you can understand that. Just as Eucora's core value extended beyond software platform and was in the motivational mindset behind the software, DLF's core value and mindset goes beyond the language itself. DLF's core value resides not solely in the language, but in the very mindset that the language embodies. D is a byproduct of DLF's mindset. D did not create that mindset. DLF's transformation has already begun. And for DLF to flourish, it has to transform in two different levels, individually and collectively, or as an organization. On an individual level, DLF is trying to find the alignment between its IV, what it wants to become, and the IV of its stakeholders, including the contributors and the customers. But it doesn't limit to just contributors and customers, any stakeholders. It's that sweet spot in the middle that ensures that everybody is motivated and excited and are moving towards what they want to become, and the organization is moving towards what it wants to become. On an organizational level, DLF recognized the significance of how IV can align all stakeholders in common direction. Through the 15 sessions of the workshops that we had, they spent a lot of time and energy finding that IV statement of who they want to become, both personally, individually, and collectively as an organization. I will leave that to Michael and Walter to tell you what DLF's IV is, as I really don't want to steal their thunder. I urge each and every one of you to find your IV. Find that ideal vision of who you want to become in the future. A truly transformational IV is not just some traditional vision writing where you sit for 5 minutes to understand where you want to be in 5 years. It's deep work, and it takes time, but it's well worth it. For those of you who are interested in finding their IV statement and write it down, I invite you to join us on Friday at the workshops that we have. Michael and I will be there, and I will personally help you and coach you to write your IV statement, to find who you want to become and discover that. And by the way, it's already within you. It has never been without you. So I look forward to meeting you on Friday. Once you discover that IV and internalize the principles behind IV, you can use this mindset in all aspects of your life. In your relationship with DLF, in your relationship with other organizations, and in your personal, even in your personal relationships. Everyone is attracted to people who have passion and direction. And everyone is attracted to organizations with passion and direction. Combine the two, and there's nothing you cannot accomplish together. Thank you. I have 8 minutes left.
It is now questions time. Now, I should mention for people on the stream that I am monitoring both the YouTube chat and Discord. But let's start with an audience question. Over there, Laith.
Thank you for a very stimulating and thought-provoking talk. To what extent is the statement I mean, I guess it's something that one might have being a bit older, but what extent is the statement tentative, a work in progress, something that's unfolding and being refined as you discover more about what's inside.
If I understand your question correctly, you mean how static or dynamic it is?
Yeah, and accepting that it is something that might intrinsically be refined over time.
Well, and Ivy is quite dynamic. Who you want to become changes all the time. And as you move forward, you kind of learn more things about yourself. Because when you move towards a certain direction, new opportunities come in, and then you understand yourself better, and therefore you write a different Ivy statement. Actually, this Ivy statement that I showed you is my 7th edition. The one that I showed at the DConf was not this one, it was a different one. But it doesn't radically change. It's not like one day I wake up in the morning, I completely want to be a different person. It's usually my experience is that new editions are kind of get more narrowed down and more specific as what exactly you want to become. But it does change. Did I answer your question?
Yes, you did. Thank you very much.
Thank you.
I wanted to briefly ask about how do you make use of the right level of abstraction of an IV statement? So in your own personal statement, the end goal was to make a difference, but to make a difference in the world, there's many ways of doing it. It might be by directly helping people as a doctor or a teacher might, or it might be by inventing a new technology, and of course there's 1,000 areas in which one focuses. And what you need depends on the company you're in, et cetera. So how do you pick the right level of detail when creating a IV statement?
Can you ask the question again?
How do you pick the right level of detail, like how specific in what topic area? Because
right.
the more narrow you are, the less likely it's going to apply to, say, a company.
Oh, I see what you mean. That's a good question. The big distinction, I would like to give you a distinction. The big distinction between IV and goals, they're completely different things. A goal is something that you set, and usually it's time-bound, right? This is what I want to accomplish within this period of time. And once you accomplish that, then you go to the next goal, and the next goal, and the next goal, right? IV has the nature of a vision of who you want to become. There is no place, like my IV statement, if I go back, so there is no point in time that I can say, oh, I accomplished this, I'm done, right? I can always be a storyteller. I just choose different tools to get there. I identified my tools here, right? I say by teaching, speaking, acting, podcasting, YouTubing, you name it. Jobs are just tools. Tools to help us move towards the person we want to become. Now, because it has that nature of vision, I wouldn't say it's either specific or not specific. It's usually kind of broad. Like I say, I want to become a captivating storyteller, right, of life-altering ideas. Now, when I go to an organization and I say that, what are they going to do about it? Well, let's say just at Yocora, what happens is, oh, actually, we have this idea. We want to promote this idea. Let's create it. Let's work on it, because it's all stories. To me, all of these are stories, right? Now, how do I apply it? Well, I'm a coach. I'm an executive coach. I work for organizations. That's another way of telling stories. I teach. That's another way of telling stories. I speak. That's another way of telling stories. So something that's beautiful about Ivy statements and Ivy is that it doesn't limit you to one job or career, right? You're free to take on any job that you can. Of course, you have to have the knowledge and the skills, and you need to learn things along the way. But as long as what you do is moving you towards that person, you're fulfilled, because that's not a goal, right? That's just a direction. Does that make sense? So when you say you're moving towards north, then it's hard to say whether how specific or general. Well, I'm just moving towards north, right? You can be as specific as you want in the by statement to show exactly what tools you would like to use, right? And what tools you don't want to use. That's fine. But that to become statement is quite broad. Did I answer your question? Okay. Hello.
What would you say to somebody who looks at this and goes, I don't really care, it's not about me, it's not about my identity, it's just about what I get done? So it seems to me that this has this sort of the core of this is somebody describing who they want to be, and it's sort of got this sort of reflexive thing, looking back on yourself.
Yeah.
Somebody might say, I don't care, right? Like, it's not about me, I'm not important, it's just about what I do.
Very good question. And I assume that person is like some business owner or manager, right?
Well, it could be, I mean, I feel like I'm 50% of the way to that.
Yeah, okay. I see what you mean, yeah. It's a very good question. Let's say I come to you, and we have this discussion, and we want to do something together, right? And then I tell you, this is who I want to become. And you say, well, I don't care, right? How are you going to motivate me? How are you going to ensure that what I do is I'm putting all my energy and time and really kind of work through it to make it happen? Because if it's just a job for me, well, I'm going to show you the smile.
I actually mean with myself, say. So if with myself going, I don't care who I'm not.
Oh, you say to yourself.
I'm painting a caricature, right? But I don't care who I'm going to become.
Why not?
I just care about what I'm trying to do. I care about what happens out there in the world, not about who this thing becomes. That's not necessarily what I really believe.
You and I need to talk on Friday. Believe me, because I want to ask you more questions to get there, but I'm not sure if you're comfortable answering those questions in front of everybody.
If you want to, you can go ahead.
Well, the first question I would ask is, why don't you care who you want to become?
It's not that I don't care, it's that the goals, the motivation is to do with seeing the change in the world.
And that's who you want to become, isn't that so?
I'm instrumental, not...
Then maybe that's who you want to become. You want to be an instrument of change in the world.
It's fair enough, but first things first, it's the thing out there, not me.
Why not?
Don't know.
Let's talk on Friday. Are you going to be here on Friday?
Yeah, I should be. Yeah.
Look forward to seeing you, okay?
Saeed.
Yes, Ali.
Thank you very much for a great talk.
My pleasure.
I'm going to ask you whether it's a common question to question the ego in this statement. Is I want to become a Western invention? Is this a common question that you face?
What do we do with ego?
Because this puts the ego up front, saying you want to become, I want to become.
Okay, yeah,
it's
fair enough.
claimed that there are some cultures out there that want to suppress the ego.
Yeah.
Is this a common question? If so,
oh, it is.
Answer.
Oh,
Yes.
actually, it is. Thank you so much. One of the principles of Ivy is that, I'm going to say it, but don't get angry, is that everybody is selfish. Not in a bad way, in a good way. I want what I want in my life, right? And I want to see that's happening because that's the potential I have, and I want to see that potential throughout the world, right? To bring up goods and everything. So that part of self is actually a positive thing. Ego, when it comes negative, is I want everything to myself and nobody else. The principles, another principle behind Ivy is that I have an Ivy and I want to become somebody, but so does everybody else. Ali wants to become someone, and I should care about that if I want to see you motivated and work towards what we are working towards together. Otherwise, I'm just bossing you around and I'm just commanding and controlling, right? Command and control doesn't go anywhere, and I think we all know that. So the only thing for me is to accept that Ali, selfishly, in a positive way, wants to move towards something that he wants. I better recognize it, and I better work with it, because otherwise he's not going to be motivated. If I put him in a situation that is opposite of who he wants to become, he sees the whole situation pointless. What's the point? Why am I doing all these things? I'm not getting anything out of this. Okay, so you're giving me money? Okay, I'll work for your money, but I'm looking for something else, right? But deep inside, Ivy, I would say, doesn't contradict the other philosophies that talk about like being egoless. Right? So, for example, someone like Eckhart Tolle. How many of you know Eckhart Tolle? Have you read his book? Right? Okay. So he suggests the idea of don't live in the future or past. Live in the present. Live in the moment. That's where life is. Right? And one of the questions that I get is that that's completely opposite of what I'm talking about. But it's not, because living in the moment and planning for the future are completely different things. You think about future of who you want to become because you need to have direction in life. Not having a direction is Alice in Wonderland. If you don't care where you're not going anywhere. But then once you choose that direction, then you take your steps in the present. Now you're in the present, you accept everything that happens right now in life, and you move forward, but you have a direction. So it's not living in the future. Ivy doesn't mean you have to live in the future and start daydreaming every day all the time. And it's not that, have you heard The Secret? It was like a documentary a while ago, a book, the law of attraction and all of that. And it's not that either, just put like a check with the $1 million on your ceiling every night and just look at it and then you're gonna get $1 million someday. It has nothing to do with that. It's just all about find that direction that you're moving towards in your life, define how you want to move towards it, and ask yourself, why do I even want to move towards that? Share it with other people. Of course, share it with people you trust. I mean, you don't have to share it with everyone. I'm comfortable, I share it with everybody. But then so they know what motivates you and what demotivates you. That's important. Because if they know what demotivates you, then if they put you in a situation that demotivates you, then they're not going to say, oh, this guy is demotivated. Well, you put that person in that situation. It makes it very clear where I'm moving towards. And if the company I'm working with, if my partner, does something or puts me in a situation that's opposite of this, well, at least she expects me to be demotivated, right? Did I answer your question, Ali? Yeah? Okay.
Oh, and that's all the time we have for questions now. So thank you, Saeed.
Thank you, everyone. Thanks.
And as he mentioned, he has the workshop on Friday at the hackathon, which sounds like a perfect place to go to if you're having an existential crisis. So please. All right. We got a few minutes break here. Go get a coffee or whatever, and back here for 10 so that we can start the next talk. Hello, everyone. Make your way back in, please. That includes you all downstairs drinking the coffee that I really want. You got until Walter sits down, and then we're starting. All right, and Walter has sat down, so if you're not here, well, what can I say? Timon, welcome. You're going to give us a talk about types and tuples. I love it. I didn't even have to say programmer energy that time. All right, take it away, Timon.
Thank you. Well, this will be quite a contrast because now we are going to learn what happens if you learn entirely too much about arcane language details. So first, maybe what is this talk? Maybe the title seems a bit weird to you. So originally I proposed 2 talks to choose from, basically. So types in D talk and the tuples in D talk. The issue was, like, the types talk fits the conference schedule, but the tuples talk was what everybody wanted to hear. So I'm going to do both, which is what usually happens in D. So basically what I'll do is I will freely associate about this type system for hopefully around 45 minutes. I did cut some of the more arcane type system things in favor of tuples. So first a disclaimer. So we will look at some quite dark corners of the language. So this is not a particularly representative sample of language rules. So here be dragons. So be prepared. So first, let's discuss what actually is a type. So a type is metadata describing the runtime effect of an expression, so in a relatively general explanation. Often, types also classify values for arguments and results of expressions, which is basically the way that D is using the term internally. So like the type of 2 times 3 is int, which means that if you evaluate the expression 2 times 3, you get the result, and the result is an integer. Often, types also track side effects, and indeed we have like all those nice attributes, like pure, safe, and no throw. There's also no GC. Sometimes types prescribe a memory layout, which is the case in D. It's not always the case. So sometimes types just tell you what to expect. They don't tell you how to represent it, and the runtime system can actually choose this for you. So indeed, this is not the case, which means you get control, but the compiler gets less flexibility. You have to do the optimizations yourself. Type information is often partially or fully erased at runtime. So there are languages where you have an untyped language, then you build a type system on top of it. If you type checks, that means things are fine, but you actually don't need to keep the types around at runtime. In D, as some information about the types is kept around at runtime, but not all of it. All right, so one interesting tidbit is that early type systems were mostly about proving consistency or termination. So for example, if you know about the set theory in lambda calculus, there are those tricky things, like this is a set that cannot decide whether it's a member of itself. And this is a lambda term that runs without termination, which is kind of, well, it reduces in one step to itself, right? So you take this function, you substitute it for x here, and then you just get the same term again, which is quite annoying if you want to do logic, because, well, if you want to do logic, you don't like self-referential things. Interestingly, in like modern programming languages, this is very seldomly done. So you don't prove termination, you actually directly introduce language constructs that don't terminate, and they very much type check. All right, so let's jump right in. In D, we have some basic types. You have like short, which is a 16-bit integer, int, float, double, all the jazz. On the right-hand side, you have some expressions that evaluate to a type of that, to a value of the type. So basically, there are values already. And then we store them in variables of the type. So one thing that's interesting here is that this one here, it's actually of type int. We can store it in I anyway, even though in general we cannot store ints in I. So what D does for integral expressions is it tracks the entire range of the type, of the expression, sorry, which works using interval arithmetic. And a nice exercise is actually to derive the best possible interval transformer for bitwise operations, which is one of the things I did, which is now in the compiler. All right, that's I guess as much as we'll talk about value range propagation at the moment. It's quite nice because you get to actually cast things, but you just have to be explicit about cutting off the trailing bits, for example. Then D also has some type constructors, so they combine basic types and also user-defined types in some interesting ways. We can create an array of int. We can say the elements should not be mutated through this reference. We can say the elements are immutable. And then the type system kind of has some checks and guarantees related to that. There's also static arrays that have a fixed size and are value types, whereas here this is actually a reference, which you can see because we update A and we see a change in B. This cannot happen with immutable things because they cannot change for any reference. And finally, there's also associative arrays. So one thing about type constructors is they're magic, and users cannot define their own type constructors that behave in this way, which is maybe a less desirable property. All right, then another thing that's D actually copied from C and C++ is there are L values and R values. I mean, it's quite standard in modern programming languages, which means expressions behave differently when they're on the left-hand side or on the right-hand side of an expression, and some expression can only appear on the right-hand side. Some types are actually only meaningful for L values, but you can still get R values of the type. So for example, here we have an enum n. So this is an R value of type const int, and the value is 5. So it's a bit confusing what the const int actually is, because it's actually just an int, right? And you also cannot assign a new value to 5, even though it's of type int and not of type constant. This is because you cannot assign to R values. Fun fact, in early versions of Fortran, I think you could actually do this, and then everywhere else in the program where you used 5, it would then actually just be 6. This is not the case in D. D is a sane language, of course. Then, so L values you can usually update, except if they're const. But well, here M is not const, but we can assign a const into it, right? So basically, const doesn't do much for R values. We will see some exceptions to that later. Indeed, there are also storage classes. So who here thinks this is saying immutable int? A few suckers, okay. So well, actually, yeah, that's usually what people think it means. What it actually is saying is this is an immutable int x equals 2. And then this is also a bit confusing because you can actually write the type immutable int. That's just not how this is parsed, right? So if you have this kind of storage class, it applies to the entire declaration, not to the return type. So how in practice those things interact is that you can only specify one of them, and then the other one will be automatically added. You can actually write this. It's not considered redundant. And this is especially important for functions. So for example, here we have an immutable int pointer foo, and to like many people, this looks like immutable int pointer. But actually, it's the same as for the variable, and it applies to entire declaration, which is the same as qualifying the implicit context. So if this is a member function, it qualifies to this. If it's a local function, it says you can only access immutable closed-over variables. So this can sometimes throw off people because ref also qualifies a function, but in fact does relate to the return value. Right, so even for ref, this is the same as this. So this is a ref function, but actually what it means is it returns by ref. So and then there is this one detail about ref on delegate types. So who thinks this function returns by ref? Nobody. Okay, this function actually returns by ref. That's clearly what it says, right? Who thinks this function returns by ref? Nice. Yes. You're courageous and right. Now, who thinks this delegate returns by ref? Well, it already says it doesn't, right? So you should get the hint. So what this is actually doing is it is saying the delegate itself is a reference. Then this should say that the delegate returns by reference, but the parser rejects it. And that's, even though for immutable, both of those things work, right? So maybe that's something we can fix on the hackathon. For functions, there is this interesting detail that you can overload them. So the type of an expression actually drives behavior, which means you cannot directly erase types from D programs. You first have to do some lowering of syntactic sugar. Here, the constant R value actually strikes back. So here's an actual use case for this. So if you call a foo of 2, it will call the first overload. If you, however, call foo with a constant, it will call the second overload. I mean, I don't know why you would do this, but it works. Then another thing that's quite interesting about overload resolution is that actually if you have overloaded functions overloaded on delegate types and you put in this sort of template delegate literal, it will actually result in a template instantiation per overload while it's trying to match. And you can actually, in this delegate itself, introspect on the argument type in order to decide what is the return type. And so if you ever wanted to implement this sort of automatic enum scope lookup, this is one way to do it. Okay, so next point, there is a type deduction in this. So here we have auto x equals 2. So who thinks auto means infer type? All right, a few suckers again. So auto actually doesn't mean infer type. It's not a wildcard replaced by a type. It's just needed here to introduce a declaration, and what it's actually saying is, automatically determine where to put this variable. This is the same meaning as it has in C. Because, well, if you didn't write auto, it would just try to assign to an existing C. You can actually also have type deduction if you just put any other storage class in front of the declaration not to introduce it. So this is another way a const R value may actually take effect. So here, this x will actually be a const variable, even though it doesn't necessarily mean much on the right-hand side. So some limitations of type deduction in D. So one is that it only works in the forward direction. So for example, here we say auto x equals empty array, and then we try to append. Maybe it looks like, it's readable, okay. So we try to append 1 to the array, and it doesn't work because D thinks x is a void array. And then if you actually say, well, no, it's an int array, then it works out. Yes? Very good point. No, it isn't, but it should be.
I believe it's an array of no-throw bottom types.
Well, it should be, an array of no return, but it is currently still a void array.
Okay, thanks.
Yes. Yeah, but I fully agree. It's also on the slides. So another limitation of type deduction is that you can actually break code by returning a more refined type. So here we have D that refines C. And we want to return, so first we have two functions that return C. And now we want to change foo so that it returns D. And this actually breaks the caller because of type deduction. And if you write the type explicitly, everything works out because a D is still a C, and we can reassign result. So basically, be careful when using type deduction with code you don't control, and may change result types. All right. So I mean, you've already seen maybe I wasn't too happy about some things. That is because you cannot be happy about everything. So there's a huge list of things that you want the type system to satisfy. And not all of them can be true at the same time. And the art of designing a type system is basically finding synergies between those things and kind of, you have to choose. So for example, expressive type systems are nice because your code is self-documenting, that the compiler may even check it to some extent. Metadata is accessible by tooling with standard meanings, and it detects errors more efficiently than tests would. So, I mean, probably a lot of you have had the experience where you wrote a script in Python, you ran it for like 5 minutes, and then in the end it crashed while printing the result because you got some formatting things wrong. That's something that the types help you with. They won't even let you run the code, right? But you probably still need tests unless your type system is maximally expressive. Expressive type systems can lead to some annotation overheads, and those type systems are more likely to become non-modular if you make them more expressive without keeping this in mind. One point is that most languages tend to evolve from less expressive type systems to more expressive ones. And this is actually much harder than just designing a simple type system that is expressive from the start. But there are very simple systems that are very expressive. This is also something that people sometimes don't understand, because their experience is as languages get more expressive, they get more complex. But it doesn't need to be that way. It's just hard to do in practice. So I talked about modularity. What is this? Modularity means you're able to factor out patterns into functions or aggregates. And type information, therefore, must be able to cross function aggregate boundaries. So now we will have some example of a successful refactoring. So here we have y that is x plus 3. So what you can now, of course, do is just say, well, we have a function that adds 2 numbers. And then we can replace x plus 3 by a function call. And what this function tells you is what it expects and what it returns. And in this example, this is all the information you need. This is, however, often not the case. So for example, here I'm taking advantage of value range propagation to put the lowest 8 bits of x into u byte y. Now I try to somehow extract this into a common pattern where we mask out a certain number of bits. And now it doesn't work anymore because mask low returns int. And unfortunately, there's actually no way for me to fix this, because the type system here is tracking information, namely value ranges, that is actually impossible to thread through this function. So in order to make this refactoring type check, we would need to annotate somehow what is the range of the result based on the range of the arguments. Exactly. So this brings us to the next topic. So there's type safety, and if you have a type-safe language, your types define invariants on the program state. In D, we have safe values for each type, and some types also come with constraints how they can alias. And all operations, like safe operations, have defined behavior if the invariants hold and they preserve invariants. Of course, type safety is not always, it doesn't always hold. So for example, here we have a Boolean that is initialized to void, which means it's not initialized. And then we have if B, it writes B is true. If not B, it writes B is false. So who thinks this prints B is true? Who thinks it prints B is false? Well, I mean, if you've raised your hand at any point in time, you're right on my machine. Basically, it will print both B is true and B is false. And this is the kind of behavior you can get if your program is not type safe. Of course, type safety comes with its own trade-offs. So, like a really nice thing about type safety is that programs never lie, and types are actually compiler check documentation. There is quite a bit higher confidence in refactoring because, well, at least you will not introduce undefined behavior. So your tests will actually be able to catch bugs. A nice thing about type safety is that it can support the safety guarantees. An issue with type safety is that, of course, perfectly fine programs may still be rejected. And because people like type safety and they don't like having their programs rejected, you always get this sort of pressure to increase expressiveness and modularity of your language. So as a consequence, you usually get a bit larger annotation overhead. So this is what is colloquially known as attribute soup in D. So because D, of course, doesn't do either no type safety or type safety, because it's D, it does both, right? We have system. This is an annotation for functions, and basically this means types are suggestions, and programmers are infallible. If your function has a bug, and somebody decided to call it, it's on them. They shouldn't have trusted your function, right? Then there is trusted, and this means the function has a type-safe interface. So it behaves exactly like a function that is safe, but internally, maybe the compiler doesn't know about this. One interesting thing here is that the programmer of the function is considered infallible by the language, and the caller is a bit restricted, but adversarial. So the caller may not pass unsafe values to your function, which means it's restricted, but the caller is not infallible. They're actually actively trying to break your function. This also means that people who write trusted functions are the only people who are actually able to be blamed for memory corruption. So if you do memory corruption in system codes, well, you're not the one who called your function, right? It's not on you. If you wrote memory corruption in safe code, well, it's not on you. Somebody who wrote the trusted function screwed up, or just the language didn't type check your program properly. And I actually didn't say what safe means, right? This means programs have defined behavior. Programmers are adversarial, so not competent at all. It doesn't really matter. I mean, you can write safe code even after getting high on milk at DConf. And callers are restricted but adversarial, which also means that safe and trusted have kind of the same interface. So from the outside, it doesn't matter whether a function is safe or trusted. So the overall goal of this entire thing is that type safety and lower level control coexist in the same program. And that trusted functions or the language should be to blame for any remaining holes in safe code. So this introduces a sort of compile time modularity for memory safety. The runtime effects of memory unsafety are still unrestricted. So if you screw up memory safety in a trusted function, where this manifests may actually be in a safe function. So more generally, D prevents other side effects. So all function types have an effect annotation. If it's left out, that's still an effect, right? It just means it's unrestricted. You can do anything that the language allows. So as we see in safe means no memory corruption. It also means no undefined behavior, because memory corruption and undefined behavior are kind of related. So this is the data side, and this is the behavior side. Then pure is intended to mean no mutation of global state. It's mostly that. It's actually by design mostly that. One design decision I agree with is that pure functions can allocate memory. One design decision I don't really agree with is that pure functions are allowed to mutate float rounding settings. There is no throw. It prevents throwing of exceptions, and there is no GC. It prevents GC allocation, and indeed it also means it prevents GC pauses, which is something people sometimes don't appreciate, because indeed a GC will only collect if you try to get more memory out of it. So, of course, there's a vast number of other effects one could prevent, and of course we probably will prevent at some point, because you need to make that attribute soup a bit more tasty. I have a few ideas here, but probably that's not what we're going to do. I intentionally didn't add anything here that's supposed to be realistic. So this effect tracking still has some practical challenges. So one issue is that pure is underspecified. So I think it is currently not clear when a function can be trusted pure and when it cannot be trusted pure. Because I don't really know what is the invariant that is enforced by the pure qualifier. I mean, it prevents some things, like it prevents you from accessing a mutable global state, but it's not so clear what exactly is the invariant that this enables. Often, another issue is that people want to check their code non-transitively, so they don't really care about effects that happen somewhere else, but they really want to make sure that they're not the ones introducing them. And currently, there is not really a good story for that. In particular for trusted. Trusted is quite tricky to use correctly. So it is hard to specify in a fine-grained way which operations one wants to trust. And this is particularly an issue in generic code. So this means that even the standard library now uses trusted lambdas with an unsafe interface, like this kind of thing. This has much better ergonomics than what would be the intended use of trusted, but this is also a completely wrong way to use trusted, because this lambda does not have a safe interface. So it interacts with state that is controlled by safe code outside. And if you remember, safe code can be changed by people who are drunk or high or whatever. You are not allowed to trust safe code from within a trusted function. So probably the language has to make some concessions here, because the current state is not all that nice. So another point is about inference and defaults for effect annotations. So auto functions infer their effects. Functions in template instances also infer effects. But currently there is no other way to turn on inference if you specify the return type of your function. So maybe that's something we can address. Another thing that we maybe could improve is that inference currently is sometimes a bit unreliable when there is a mutual recursion between functions. Oh, Walter has a comment.
There is a way to turn on the inference if the return type is specified. You just add opening and close the parens to the parameter list and make it a template.
I fully agree, but there is no other way, right? There's like the first way, there's the second way. You describe the second way, but there's no other way. I mean, this way that you specified that works. One issue is that your function will not be type checked unless you instantiate it, and the error message will happen in the wrong place. I mean, it's a small ergonomic detail, right? But maybe we could allow auto on functions that also specify return type and then infer attributes or something like that. So there was DIP 1028, and it proposed making safe the default. So ultimately, it was retracted because safe is not saying default for extern C function prototypes. So personally, I think you should not be able to annotate extern C function prototypes safe at all. But that's kind of not what the language does at the moment. And one point that we certainly could address anyway is that it would be nice if there was a way to switch defaults without disabling inference. So another way D tracks effects is mutability of L values. So you have an unqualified type. It can be mutated. It may not be shared. I mean, instances of T, like variables of T, can be mutated, right? Then a mutable T cannot be mutated at all. It can be shared freely as a result. I mean, I don't know if this is the best design, but it kind of seems to make sense as well. Then const means you cannot mutate something for the current reference. The other people may mutate this, and you may observe the mutation. And for about in-out, we will hear a bit more later. Shared means you can share, but you must properly synchronize accesses. All those qualifiers are transitive, and no mutation really means no mutation. And I cannot stress this enough. So I've a nice quote from my office mate is, const is so strong and provides such strong guarantees in D that it's essentially almost useless. So personally, I don't use it very often, and you should also be careful because it will really restrict you. All right. So let's get back to the attributes. So the challenge I've set up is to create a delegate that composes two int delegates. So here, the type of that thing will be a delegate. It is to int delegate that takes an int, right? And it will return an int delegate that takes an int. The function itself can, of course, be safe, pure, no throw, and no GC. And this is my implementation. Who can see what's wrong with this? I mean, yes?
The delegate are not safe, pure, no throw, no GC, so when you call it's gonna fail.
Well, I mean, it doesn't call it, right? It just returns an int delegate that returns an int.
All right, you're in front of the, not for me, so.
Ah, I'm standing in front of it. Nice. Well, I mean, I guess we should get going. So the issue is basically that those delegates are unqualified. So if you pass in two safe delegates, the result will not be a safe delegate. And basically, currently, there is no way to write a polymorphic compose function in this way that actually correctly preserves the qualifiers. And this is a pure modularity problem. So if you actually inline compose into its callers, this will work because here this literal will automatically infer the right qualifiers. So a less contrived example that often comes up in practice is the virtual op apply. So we have some AST nodes, we have some components, we iterate over it with op apply. In practice, people now have to kind of write op apply for all combinations of qualifiers on op apply and the delegate. And this is kind of a burden on library authors. And in practice, most library authors only decide to support some subset of qualifiers. So maybe they will require the callers to pass in a safe delegate, or the op apply will not be safe, and so safe callers cannot call it, and so on. So in general, D is usually designed in a way that allows type checking the identity function. So, and in practice, you can get relatively far retemplated functions. So for example, this ID function here works, right? It will preserve qualifiers correctly on the delegate. And the issue with templates is, by one, it's either templates or virtual calls, so you have to decide. And in practice, you usually decide for templates, and then you hamstring yourself because you want to have virtual calls in your program. And one reason for this is that IFTY does not match lambdas very reliably, and that's maybe also something you could address. And in total, this leads to template load and somewhat larger compile times if you want to support all of the attribute combinations. This entire thing has, of course, happened before, so it's also the case for mutability qualifiers, and this is why in-out was invented. So basically, this single function replaces all of those three, and it has a single address. And you could, in principle, think about doing exactly the same as for the effect annotations, but I will argue against it because I think in-out has some issues. So one thing is there's only one in-out qualifier. But there can be multiple functions in your program. Which function relates to which in-out annotation in any given context is determined by ad hoc rules, and I think they're somewhat inconsistent. So for example, here we have an ID function that returns a delegate that turns an in-out int into an in-out int pointer. We actually cannot call this with a function that takes an immutable int and returns an immutable int pointer. This is because those in-outs here refer to the function call that occurs when you call the delegate, and not to the function call that occurs when you call the identity function. And there's actually no way to write this identity function here that works for immutable, const, and mutable. Another issue with in-out qualifier is that in-out qualified data can be stored in aggregate. You cannot have a struct field of type in-out int pointer, for example. So this also means that in-out is incompatible with most of the Phobos range API because it permits zero data abstraction. I mean, Phobos anyway goes out of its way to accommodate in-out, and I think it's maybe not worth it. So of course, if you don't like it, you try to break it. So one observation I made is that nested functions actually share in-out with their enclosing function. So if there's any in-out in the closing function. However, as we've seen, high-order functions within return types have their own in-out. This is inconsistent, and interestingly, the obvious way to exploit it has been patched. So here we have a bar. It looks like an in-out function, but this in-out here is actually the same as this in-out here and this in-out here. So because it returns in-out int pointer, we can actually return the parameter of the enclosing function, and then we can return bar. And this is accepted. And then an interesting thing that happens is if you look at the type of foo, you actually get something that returns that turns an in-out int pointer into an in-out int pointer delegate. But if you call this function, what you get is not an in-out int pointer delegate as claimed. What you get is a const int pointer delegate const int pointer. So what the compiler is doing here is it's fixing an inconsistency here with an inconsistency down here. And in this kind of tricky way, it prevents me from breaking the type system. So a nice consequence of this is that actually the generic template identity function preserves the type for all argument types. Well, actually it doesn't, right? So ironically, there is this type T here, in-out qualified in-out int pointer delegate, that if you pass it to an identity function, it returns something of a different type than what you passed in, because some of the in-outs here will be replaced by const. So the effort to preserve type qualifiers through an identity function actually prevent us from preserving types through an identity function. And then, of course, there's a way to circumvent the patchwork. So here, I can mutate this immutable global, or actually a DSEC fault at runtime in this case. I'm doing the same thing as before, but now I'm actually just closing over the address of bar. And then if I call it here, it will not do the const patch, and we will actually get an in-out function, and then those two in-outs get conflated. We pass a mutable thing, which means in-out is instantiated with mutable, even though this thing here is originating from this in-out, which is instantiated with immutable. So we get a type panning between arbitrary qualifiers. The return parameter attribute has some similarities to in-out, but it's not as broken. So it is still the case that interaction with nested and higher order functions seems a bit tricky, but there's a way to make it work. Return scope pointers and return references cannot be individually stored as struct fields, but at least you can store lifetime limited things in structs, right? So there's only one name for return attribute, that's the same as for in-out, which means lifetimes tend to get conflated. However, because you don't need substitution, return avoids many of the in-out pitfalls. So there's another comment. All right. Okay, so I don't have that much time, but I guess we'll count this as a question.
Okay, if you have multiple returns in the parameter list, the compiler will select the one with the smallest lifetime as the lifetime that's actually being returned.
Yes, exactly. Which means you cannot preserve the longer lifetime of one parameter if there is some parameter with a lower lifetime. Yeah. So one way to address this that is often done, and it's also done by languages like Rust, is to have some sort of parametric polymorphism. So for example, here we explicitly pass in the mutability, and this allows you to have different mutability for the argument and the return. So you can actually thread through a polymorphic function through a function, and it works out, or you can have a polymorphic function that threads through a function. There's the same thing you can do for effects, and then you also get to solve this op-apply issue in a quite nice way. Of course, one issue I've heard mentioned in this context is that this may increase compile times quite significantly, and then maybe it's also not worth it. So we'll have to see how to address this kind of thing. An interesting thing about CTFE is that it's technically part of the type system, but CTFE functions cannot manipulate types directly, and they should probably also be fixed. Then a nice tidbit is that we have forward references and introspection. So here, if X is not defined, we define X. Some people think they should work, some people think it should not work. Here we thread it through Y. I think it should not work. Maybe some people think it should work. At the latest, at this example, people start agreeing with me that it should not work because which variable here is defined actually depends on which module you pass first. You get inconsistencies between different compilation units. And I actually wrote an experimental front end with explicit dependency tracking to try to address this. So it catches ambiguities and contradictions. Unfortunately, it stopped compiling with DMD 61. Ironically, the reason was I went too crazy with code generation introspection. So the problem I tried to fix with this caught me. Of course, no talk about types and tuples would be complete without the infamous type tuple. So I won't go into details here, but it has some restrictions, and I think it is not a tuple type because it's not a type, right? It's a nice metaprogramming tool, but it doesn't fix the need for tuples. So what is a tuple? That's something that contains multiple values. You can get back out whatever you're stuck in, and it's not more than the sum of its parts. So it's a product type, but it's sum. Yeah, it's a bit annoying. It sounds a bit like struct, and there is a standard type const tuple, and the question is what is missing. So this is a simplified implementation of that. The actual one is a few hundred lines, I think. So what do you use a tuple for? You create ad hoc groupings, and for very localized data structures or for returning multiple values. So you shouldn't really use it in interfaces all that much. So what is missing is actually you cannot stick things into tuples. So you cannot stick an in-out pointer into tuple. You also cannot get things out because of return. So we cannot get back out A and return it because it has been its lifetime has been conflated with the local variable B. So at the moment, it's kind of not achievable to have tuples, so you can stick things in and get them back out. But we can opt for the next best thing, which is destructuring. And actually, There was a pull request in like 2011 that implemented the structuring. It was never pulled, and basically the issue was, well, we need a full tuple design, otherwise this may restrict us too much. So the only thing I think that's wrong with this proposal is that that this looks weird. Otherwise, I would say slightly generalize this and ship it now. Then there's this one thing that actually slipped past Walter and Andre. You can actually, so here, this is not yet it, but so you have x and y, we iterate over an array, so we get index and a tuple. By the way, this formatting really should be fixed, it's completely useless. But if you map the array such that it becomes a range, it will actually match the tuples. This is a bit annoying, and it actually runs exactly into this thing where you have to have a design that now accommodates this. So why are there no tuples? So I implemented static for each. The issue is that there is a very small design space for static for each. In tuples, there are many moving parts and has to fit into the existing language. Different syntactic preferences exist. I think the others also have some issues, not just mine. And then, of course, you want all of those different things. And I tried to write this up in a dip. It still needs some updates, and any help is, of course, welcome. And finally, here are some hackathon projects that I think would make sense. Yeah, so sorry for not managing my time right. I removed a lot of things from this talk. And I know all of you wanted to hear about tuples, and now it didn't work out. But feel free to talk to me directly offline, or now during the question session.
Oh, thank you, Timon. That was actually your first DConf talk. I didn't know that. So another round of applause for it first time, hey? All right, questions time. Again, I am checking Discord and YouTube here, but let's start with John over there.
So you've shown a lot of complexity in this, right? You're showing all the ways that all the complexity we've got doesn't quite add together, and even when it does add together, it's pretty complicated. Do you honestly think that it helps write more correct, useful programs faster with less errors?
Well, I mean, there's always the distinction between user code and library code. And usually what happens there is the library author writes something, a user complains. And what you want to happen in those circumstances is the language has an answer for it that the library author can just take off the shelf. Right now, I think library authors have a lot of frustration because users come, they have valid concerns, they want to support them, but it's basically impossible.
More questions? Anybody with a question? We'll read out this comment from Ricky, though. It is unfortunate that there is no way to disable TLS transitively. This is coming up quite a bit lately. It would be cool to see D have a solid effect system.
Want to thank Timon for this talk, pointing out every mistake I've made. But I like that. And a lot of your examples I want to put into the D specification, so at least by understanding those things, they'll get to understand the type system a lot better, and it'll be less confusing for them, even if they find the holes to be frustrating. So I really appreciate the work you did putting this together and enumerating these issues. I think it's really great work.
Thank you, and I also really appreciate all the work you did on the parts of the language that I like. Which is actually a lot. I mean, in practice, I mean, people run into some of those issues, but some of them don't matter all that much.
Come on, somebody else has got to have a question. Yeah, over there.
In terms of the use of tuple, like in the Python world, a common use is just to return multiple values from a function, let's say like a function and its gradient, and having a nice clean syntax to do that makes writing code very quick. How realistic do you think it is based on the work you've done on your dip? Have something like that in D?
Well, I mean, I have an implementation that kind of works. The devil is in the details. Basically, one issue that needs to be addressed is what syntax do we use? And there's, of course, a lot of bike shedding on this. And the other one is how exactly does it work out with lifetimes? Because in D you have like moving, you have destructors. So how that interacts with matching is an interesting question. But I mean, it's definitely realistic that this works. I mean, we can make it work. I have a branch here that, so here you can actually return a tuple and match it. And it will have the right semantics, except maybe if you have destructors involved.
Yeah, we got one more question.
In my experience, the only thing that in-out buys us is that if you have like member functions that treat like, mutable, immutable const with equanimity, then you can use it. But otherwise, I haven't really seen any use cases. So I'm just wondering, what does all this added complexity to support in-out actually buys us?
Well, I mean, I think there are nice use cases for in-out. Right? Probably currently it's not worth it because I think there are simpler designs that achieve what in-out wants to achieve and do it like better. The nice thing about in-out is, I guess, it's really easy to type check. So you don't need to have some sort of scoped context, and so it compiles faster, which I think is, yeah. I think that's better.
But for users and library creators, I don't know, do they really care about that?
I mean, personally, I don't really care about it because I tend to avoid qualifiers. But I mean, some people like it. But
thanks.
All right, cool. That's it for question times. Thanks again. All right, you all know the deal. We got 5 minutes of break, and then we'll be back at it for the next talk. Okay, 10 minutes. Attention, everybody downstairs. Come on up. Come on up. We're about to start a talk. Let's play a game for everybody that's already up here. Let's play a game. It's a good little game. Guess how many people we have in attendance this year? Don't look around. That's cheating. 42. Come on. Can't pull that one on me. Pick a real number. 93, lower. 72, higher. Lower. Lower. Higher. Somebody say 30? Higher. Lower. Lower. 75. There we go. We have 75 in attendance this year. Now, you only have one chance at this. We're not going to do high or low for this. How many more people is that than we had last year? No, it's not 15. It's 10 more people than we had last year. So, woo, we're growing. All right. I was using Walter sitting down as the motivator to get us moving last time. Where is Walter? Where did he go? All right, you got 1 minute, Walter, and then we're moving on without you. How you doing, Razvan? Yeah, let's repeat that when we've got some volume on the mic. So, how are you, Razvan?
I'm a bit sad that Walter doesn't care about my talk.
Yeah, come on, Walter. Care. He's not going to care. Yeah, there's one thing that I should mention, though, before we do continue. The staff has pointed out that there are, in fact, toilets over there, so don't feel compelled to do the stairs every time. Unless you want coffee, you know. We're not going to put coffee at the door there, so you're still going to go downstairs for that. All right. It seems a lot like Walter doesn't care about your talk. Sorry.
We'll have to move on.
We'll just have to move on. You know, everybody that's done this before, we all know Razvan. He's done a few talks now, and he's going to talk about a very interesting subject to a lot of people. DMD is a library. So please, applause and take it away.
Thank you. So for those of you who don't know me, I'm Razvan, and I'm a pull request and issue manager for the D-Language Foundation. So before we get into this, I just want to share with you that, so what's the purpose of this talk? When I started contributing back in 2016, DMD as a library was one of the first projects that I contributed to. And what struck me is that I was kind of the only one doing work on this front. And that was a bit odd because it seemed that this was a very important project for the development of the ecosystem, right? So I did work for a bit. I even have a talk on this. But progress has been slow, and that was mainly due because although most people consider this to be an important project, the expectations and which direction we should go don't actually match up, right? So it was kind of hard at times to make progress because there were some people that were having some sort of, well, they didn't approve the additions and so on and so forth. So since as of this year, this has also become one of the D-Language Foundation's priority, I figured that I would just bring together like all of the past decisions and what has been done up so far, mostly to kind of create a sort of database for people that want to contribute on this front, but also to kind of spark up discussions on how to move forward. So what I'm going to touch in this talk is we're going to talk a bit about how compilers are organized and see exactly how DMD basically is organized. And then we'll see what are the goals of the compiler library, what has been done so far, the limitations, future work, and conclusions. OK, so basically, I guess most people in this room are familiar with the compilation phases. But for those who are not very well versed in compilers, you basically have the source code, which is a text file, and then you have lexing. You transform basically the source code into a stream of tokens. Tokens can be identifiers, delimiters, keywords, and so on. And then in the next phase, which is the parsing phase, you use those tokens, you consume them, and you create an abstract syntax tree, which is basically a representation of your program.
Then during semantic analysis, you traverse this tree and you enrich this tree with type information. After you've done that, you do code optimization. So basically, you try to get a minimal version of this tree, right? So that when you generate code, you generate the least possible code. Now, this is like a general organization. You may also have like some sort of intermediate code generation after you've done the optimization pass, right? And then do another optimization pass on the intermediate code, and then finally do code generation. Actually, DMD does have some intermediate code, but that's not very relevant here because when we're talking about DMD as a library, we're mostly referring to the front end. So it's basically the first, let's say, 4 stages: lexing, parsing, semantic analysis, and code optimization. Now, let's see how DMD implements all of these phases. So basically, lexing and parsing is done in the same phase. So initially, if you had like a separation between lexing and parsing, you would first go through the file, through the text file, and create a stream of tokens, and then you would have to like get every token in sequence, right? Well, DMD does this at once, so you have like a lexer class, which gives you the next token, or you can allocate a token, or peek past a parentheses, and so on and so forth. And then you have the parser class, which can parse a module, an expression, a declaration, and so on. And basically, the parser methods call the lexer methods, and they create an AST. Now, the AST is formed of some classes, and these classes also are put up in hierarchy chains. So for example, for expression nodes, you have the root node, which is an expression, and then you have binary expressions, call expressions, unary expressions, and so on and so forth. And there is an inheritance chain there. That's similar for declarations, for symbols, for statements. Now, what's interesting here is that the AST nodes contain all of the information that you need for a specific node, right? So for a compiler developer, so this is when I started working on. So currently, there has been some progress on this. So the organization that I'm presenting now was back in 2017. Now it's a bit different, but we will get to that, okay? So what was interesting is that semantic analysis and the optimization pass were all methods in the AST nodes. And after the AST is created after the parsing phase, you would just traverse this AST by calling, for example, semantic on the function declaration node. And then that particular method would recursively call semantic on the children nodes, right? So in this example, where you have the function, which has a type, a void type. It has a parameter declaration. Here, you would also have the string as a type node, but for brevity, I didn't include that. And then you have the body of a function, which contains an array of statements. One is an import declaration. The other one is a call expression. So when you called semantic on function, you would then call semantic on the body. And there are multiple semantic phases, but that's not very relevant for this talk. Right. So in short, this is how DMD is organized. So you have lexing and parsing, and then you have AST nodes, and that's all to it. Now that we are accustomed with how DMD organizes its code, let's see what are the goals and how we should transform the code so that we offer it as a library. Well, these goals we didn't extract them from a specific use case that we had. We kind of looked at what LLVM was doing with its compiler libraries, and we tried to do the same in our case. So we wanted to have a separation between compilation phases. As you've seen, that wasn't, I mean, the phases were separated, but if you wanted to just build a parser library for some reason, that wasn't possible, because you needed the AST nodes, right? And the AST nodes contain semantic information. So if you wanted to create a parser library, you would still end up to package the entire compiler code base over there. We wanted to have the ability to modify AST nodes. Again, that's not possible. I mean, you can subclass those classes, but you can't actually modify them. You want to have the ability to modify the compilation phases, right? So if you want to do semantic analysis differently for a specific node, you want, for example, if you have A plus B, and for some other reason you want to do subtraction for them, you should be able to do that. And that also wasn't possible. Also, you want to have the ability to ask the compiler for any kind of information. Any kind of information that the compiler has, you should be able to query it, and that also isn't possible because as the compiler developers know, semantic analysis creates and destroys some information, or can create or can delete AST nodes, and so on and so forth. So after you've done semantic, the tree doesn't really resemble its former representation. We also want to have the ability to use multiple instances of the compiler in the same program, right? So imagine that you're implementing a language server protocol and you want to compile things in parallel, right? So currently the compiler does share some global state, and it's impossible for you to do multiple things in parallel. So for example, if you have some code and you want to compile it with DIP 1000 enabled, and also you want to compile it with DIP 1000 disabled, you cannot do that in parallel, because you basically have a global variable which says if DIP 1000 is enabled or not. And also, we wanted the library compiler and the release compiler to share the same code base, right? We don't want to have different code bases for this. And we don't want our changes that we make to create an API for the compiler library to to incur a performance penalty for the release compiler. What we weren't concerned of was incremental compilation. So at the point where I started, incremental compilation seemed like such a far distant goal, and even as of today, I can't really envision the changes that are necessary to get DMD to do incremental compilation. Maybe it's possible, but I think the code base, or maybe it would just be simpler to implement it from scratch than use the existing code base. And also, we don't really care that much about compiler library performance. At first, we just want to have a decent interface so that people can start using it, and then we can see if we can optimize it. But the compiler is already pretty fast, so if you're reusing that code, then you should be fine in most cases. Another thing that we're not worried about is the potential compilation slowdown when compiling the compiler, right? So the compiler code base was initially written in C++, and it didn't use any templates or operations that require compilation time. So if we are going to use more modern features of D, which basically come with the compilation slowdown, then we don't care that much. Now, let's see, with these goals in mind, what has been done. So we templated I'm just going to list what has been done, and then I'm going to go in more detail about each of those. We templated the parser with an AST family in order to break the dependency between parsing and semantic. We also extracted some semantic analysis from AST nodes so that we have it in a form which is easy to be modified then by users. And then we tried to use the library for the existing projects. And a simpler thing that I just listed here, but I'm going to go in depth, is to customize error handling. So before DMD, I mean, it still has an archaic error handling system, but now you can customize it, right? So if before it would just, output to standard output or standard error, you can now pass in some files where you can redirect the output for errors. So now let's see what templating the parser with an AST family did. So this is a simplification of how the compiler code, how the parser used to look like. So as you can see, you need to import the lexer because you're going to subclass it, but then you end up importing all of the AST nodes in the compiler. And since the AST nodes also contain semantic information in them, you end up indirectly importing other files that you might not care about. And then what you do is you implement the parsing methods, and you create AST nodes to create the AST. What we did was basically to template the parser with an AST family. So the user of the library is going to provide the AST family that the user wants to use, and then we're basically going to create the tree using those nodes. How does an AST family look like? Well, for example, for the release compiler use case, you're just going to import the existing AST nodes, right? And basically, you obtain the same behavior. But if you want to modify the behavior, or you want to instantiate the parser, and then maybe just do a pass with the AST that it does, but not to do semantic analysis, then you can use AST base, which contains all of the nodes that the parser requires, but these nodes in AST base are stripped of the semantic information. So they don't have fields or functions that are required for semantic analysis. Now, this kind of breaks the dependency between parsing and semantic, but it also came with a big cost. Like AST base is a bunch of duplicated code, and there were some people that weren't satisfied with this solution. So how do we fix this? Well, one way is to extract all of the methods and fields that rely on semantic information so that you end up having AST base be the same as AST codegen, right? So this is kind of the principled approach. You extract all of those functions, you put them in a file, and then AST base and AST codegen are going to be basically the same structures. But there is another approach which I tried, and that is to extract all of the functions and fields that are common for both AST codegen and AST base and put them in a mix-in template, right? And then you just mix in this code in both the AST nodes in AST codegen and in the AST base nodes. Of course, you're still going to have to duplicate the declaration of the AST nodes, but that's just going to be class something, blah, blah. OK, well, this pull request actually has been turned down because it uglifies the code, but still, I mean, and I agree, it does uglify the code, but mix-in template is like a valid feature of D, right? So if we're not using it internally because it uglifies the code, I don't see why we are expecting that other people are going to use it, right? But anyway, I kind of continued on the line of the first approach, which was to extract all of the semantic analysis routines from there and basically created some visitors. So to have a better grasp on what this meant, this is how the AST nodes look like. So you have a binary expression which inherits an expression, and you have a function which basically does the semantic, and then you can have an assigned expression which inherits from a binary expression and also overrides the semantic method. So what we did was basically pull out these expressions, so you can see in the after code that you don't have any semantic over there, but you use a visitor class which contains all of this information in a different file, right? So right now, basically these AST nodes just contain some fields now and some methods that are being used. And while after I did this, I kind of moved on to other projects in the D-related area, but I had a student, because this was kind of a simple project, right? You just pulled out some code, you put it in a visitor, or put it in a different file. It could be done easily by a bachelor's student. And she worked on this for a while before people started wondering why are we moving all of this code from one place to another? It's really not that obvious what this gives us, right? I mean, we're acting on principle, but we don't really have a use case. So with what we have right now, why not just try to get a use case, either by, I don't know, using a tool, getting a tool in the ecosystem and trying to use the MDS library over there and see, like, how does the interface look like? Do we really need this? Maybe we are fine as we are. So we started doing that, and the first project that we did was DCD, and then DScanner. Now, what is DCD? It's a decompletion daemon, so basically it just gives you when you're writing D code, it gives you some suggestions on what symbols to use. It uses libdparse, which is a third-party library that does parsing, and it uses dsymbol, which is also a third-party that kind of creates symbol tables by using libdparse, right? So it doesn't really do any semantic analysis. It just has a tree, it goes through that tree, and if it finds a symbol, it just puts it to the table there. Now, when we tried to use the MD as a library here, because we figured, like, we have semantic analysis in the MD as a library, right? So we're going to have, like, much better results than DCD does. But it turned out that it was much more complicated than that, because what that initial image with the abstract syntax didn't contain is the scoping information. So when you're doing symbol resolution, basically you need some scoping information to make sure that you have access to a symbol, right? So how does that work? Well, the function declaration, assuming it's at module scope or at some other scope, it's in S1. But then the parameter, it's not on the same scope level as the function, right? So how this is stored, you have the second scope of the parameter, which has a reference to the first parameter. It makes sense to do it like this, because, for example, when you're calling writeLine and you're in the third scope, to resolve writeLine, you need to go up the scopes or in imports, right? So it makes sense that you have a pointer to the upper scopes. You don't need pointers to the scopes that are going down, because you're not doing symbol resolution that way. And this is great, this all works for the release compiler, but sucks if you want to expose the scopes, right? Because these scopes are created during semantic analysis. After you've done semantic analysis, you don't have these scopes stored anywhere, right? And even if you did, let's say you would have like S4 and S5, all of the leaf nodes, that doesn't help you, right? Because for symbol resolution, basically, you have one line in the source file, and you need to get all the available scopes at that line. And at that point, we kind of got stuck. Like the student which was working on this implemented a sort of a hack, which was fine for his bachelor thesis, but we didn't really have a solution for this back then. But I mean, we could do it, right? We could just save the scopes somewhere in the library version. So the lesson that we learned here is we need to publicize scopes. Without those scopes, we can't do anything like maybe even implementing unused import tool or unused variables or so on and so forth. Now, the second project with DScanner, we had a lot more success. So basically, is anyone here who doesn't know about DScanner? Okay, so basically, DScanner is this tool that is used to kind of implement style on code, right? So it also uses libdparse. So we wanted to replace libdparse with DMD as a library, and we've had much more success on this. Actually, there was a talk at DConf last year by the student who worked on this. And we had to do some lexer modifications, like we added a range interface. We had to lex white spaces in new lines, because again, lexing in DMD is very fast, so you don't care about white spaces in this. But if you're doing like a tool where you want to make sure that, I don't know, you have 2 or 3 white spaces between your identifier and the parentheses, then you need this information. And while we were changing the lexer, again, there were some discussions on the pull requests, like, why are you doing this? This is going to come with like a performance penalty, or even if you put it in the version, DMD lib version, people were like, you're uglifying the code. Why not just use like, why not just inherit from the lexer and then use your own lexer? But that wasn't possible, because if you remember the code, the lexer was just defined, so, not here. Yeah, so the lexer looks like this, right? Class lexer inherits lexer, so I cannot customize it. But you could potentially do it, and it's actually cool that this works. Like, you get a second template parameter, which is the lexer, right? Which by default points to the lexer that exists in DMD, and you just inherit it, right? So this also works. And we also noticed that not all AST nodes have location information, or in some cases, the location was wrong. So we fixed that. And this project is, I would say, 70% done, but the student now was hired at Microsoft, so he's not working anymore on this. But I'm in discussions with another student to pick up the work, and hopefully by next DConf, we're going to have DScanner use DMD as a library. Now, what are the current limitations? Well, the biggest limitation is that we still cannot currently insert AST nodes with the AST family. And I have here an example. Like, let's say you want to, I don't know, log all of the binary expressions in your AST, right, in your code. For you to do that, maybe you just want to add an extra field to the binary expression nodes. How you would do that? You would basically inherit the existing bin expression and add your field here, and then just import all of the existing AST nodes, right? Because you want to reuse everything. And then you just say, the new binary expression is my binary expression. But this has an obvious flaw. Can anyone think of it? And basically, these 2 lines of code are a hint on why this doesn't work. Yes?
So children need to inherit from my bin expression, but they inherit from the old bin expression.
Exactly. Right? So here, assign expression inherits from bin expression. I have successfully replaced with my AST family, so the parser is going to create my bin expressions, but assign expression is still going to inherit from the old bin expression, not from my bin expression. So we need some sort of mechanism to also express the relationship between the AST node inheritance chain. And I am currently exploring a way in which maybe these AST nodes could be templated with a parameter which basically represents the AST nodes that you are inheriting. Hopefully at the hackathon, maybe I can implement this. Other limitations, like you still cannot obtain the scope information, but if we are able to insert AST nodes in the AST family or in the AST inheritance chain, then you could potentially solve that by just adding a scope field, or maybe existing, because there are some AST nodes that do save some scope information, and just save that scope, right? And at the end, when you are traversing the tree, you can just use the scope for each AST node. Also, information still gets lost during semantic passes. Like, the most popular example is aliases, right? So if you have an alias and then you're using that alias in your code, the compiler is just going to replace it, and you have no idea if the new symbol was an alias or if it was just a normal symbol. And this sort of information is important when you are developing tools. Okay. Most classes and methods are extra in C++. So initially, the compiler frontend was developed so that GDC and LDC can hook into it and then use their code generators. And this is kind of annoying, because, like, for example, if I want to subclass an AST node, I have to also make it extra in C++. Otherwise, I cannot override its methods. And this has some sort of limitations because extra in C++ functions cannot use some of the functionality that normal D functions use. Of course, you can just mark them as extra in D, and that's going to work. So it's not a very big limitation, but still can be annoying in some situations. And also, one thing, if you're going to use the compiler library, be careful because DMD uses null-terminated strings. So one bug that we've had is that what we typically do when we use the compiler library, you just read the file, you have the text, and then you hand it over to the parser, right? The parser receives a string, but then when it passes it to the lexer, it actually passes the pointer. So your string is not null terminated because it has a size. But then when the lexer starts lexing, you end up like reading garbage. So if you have some time and you want to contribute, there are some things that you can do to advance the state of the art for the compiler library. And actually, I have in mind some projects that I'm trying to advance. And one is to finish the dscanner integration of DMD as a library. I'm currently discussing, as I've said, with the students to pick up this work. And also, there is a person that applied that symmetry atom of code to integrate DMD as a library in D format. I'm currently trying to implement an unused import tool also to see what's necessary for the interface. And I also need scoping information there, so we need to find a way to implement that. And also, I think it's desirable to extract more semantic information from AST nodes, because right now we have AST base, which is a pile of duplicated code that keeps accumulating and keeps being out of sync with what we have in AST CodeGen. And ideally, I would like to get to a point where you can basically specify all of the compilation phases and the AST nodes when you create your compiler, right? So you just say new compiler, here is my parser, here's the AST family that I want to use, here is the lexer that I want to use, and here is the semantic analysis that I want you to do. And ideally, you can reuse as much as the existing code as you can reuse as much of the existing code in the compiler code base to do that. So for conclusions, we started with an initial set of goals, and here let's see if we manage to reach them or not. So to have a separation between compilation phases, right now we kind of have that. So you can do lexing, you can do parsing, and you can without doing semantic analysis. The only thing that's kind of a bit problematic is that the optimization pass is still tightly coupled with semantic analysis, right? So ideally, you would do you would have the ability to do semantic analysis without doing optimizations, and then just invoke the optimizer if you want to. But right now, that's not possible. To have the ability to modify AST nodes, I think that we are almost there. So that's why it's with yellow. It's almost green. We almost have it. I'm hoping that by the end of this week, I'll have a pull request that advances this. And also have the ability to modify the compilation phases. We can do that. So right now, all of the semantic routines are actually in the form of visitors. So you can just inherit the existing visitor and override whatever semantic method you want. You would still have to probably now it depends, like semantic routines, some of the functions have even hundreds of lines of code. So if you just want to modify a particular action, you would probably need to copy paste the entire code and just modify that one little thing. Unfortunately, I don't know how else you could do that, apart from maybe, I don't know, just getting small chunks of code and refactoring them out into functions, but I don't think that that's a working solution. Now, have the ability to ask the compiler for any kind of information. That's kind of complicated right now, but I would argue that if we have the ability to modify AST nodes, then you could just create your own AST nodes that kind of store the information that you need, and then you do a pass and you obtain it from there. So I think that if I manage to finish the second bullet point, then this fourth one, I have 30 seconds. Yeah. Yeah, we still have global state, so we cannot use multiple instances, and yeah, the library and the release compiler do share the code base, but what I want to stress out is that it's necessary that we have extra code that only the library uses. And I know that most of the compiler developers are reluctant to do this. The solution up until now is to just version it out with version DMD as a library, but that makes the code more ugly. But on the other hand, like, you cannot have a compiler library and just not modify the code base at all, right? So you need to kind of stuff some sort of code that's going to create a better interface in there. And up until now, yeah, so there's no performance penalty for the release compiler because we didn't actually, we didn't add code for the release path. All the code that we've added was under version DMD as a library. Yeah, I've put some useful links here if you're interested and if you have any questions.
So I have actually two questions. One is about your unused imports tool. And I've seen there's some false positives on the unused import tool because it's a complex way to get unused symbols from that because we have public imports. And when we import a module, we can't really know if the symbol is from that module or from a public import. So we need to traverse the import recursively. Is this an issue that you are aware of and you are going to fix it?
So right now what I've did, so the import tool, it's still in a basic phase, so it just imports global imports that are not being used, because I don't have scoping information, right? So it doesn't do like function level imports. So yeah, I imagine that once you have all of this scoping information, you will be able to do more complicated stuff. But yeah, you also have imports in templates, right? So if you just have like a file where you have a template decoration and you have an import there and you have only that file, you have no instantiation, you're not going to be able to tell if the import is used or not.
Yeah, yeah.
And also with the aliases, right? So if you have an import of an alias, there is, like, if that alias is substituted in the file that was imported, there is no way to know if the alias was used or not.
Yeah, I did some changes on the compiler regarding to that, but I think we need some more work to get some compiler information from that.
Yes.
And that another question is about the modification of AST nodes. Is that extending AST nodes, or is a feature that we can actually mutate the AST? So with your changes, will we be able to mutate the AST or just extend it?
So if I get the question right, if you want to define your own AST family.
Yeah, not define my own AST family, but actually the same AST, but modifying, like transform it.
Yes, you can. If you specify, so the AST is modified by the existing semantic routines. Now, if you are using the existing semantic routines, the AST is going to be modified in your code. If you provide your own AST routines, yeah, you can do whatever you want over there.
Because modifying AST has a problem where if we modify a type, for example, we need to ensure that is conforming with the semantics. So we need to run the semantic analysis again.
Yes.
Okay.
Yes. Yeah. So, yeah, it's going to be a bit more complicated. Like, for example, yeah.
I just want a note of appreciation of what you're trying to accomplish, Razvan. Those who don't know the internals of the compiler, what he's doing is like trying to convert an internal combustion engine car to an electric car and having each intermediate stage be a fully functioning car. So I admire and appreciate your efforts in this, and you know, he's really taken on a tough task to get this done.
Thanks.
Well, just a reminder to those on the stream that I am paying attention to Discord and YouTube, but do we have any other questions here? One all the way up the back.
Hello. If I can make a brief note, more than the question, but a lot of the kind of things that are being discussed here is not so, like you mentioned, scoping information. The kind of the general issue is that we don't have a dependency graph in the compiler. So if you imagine, you know, we have a.
Sorry, I can't hear you.
We need a dependency graph.
Okay.
In the compiler, so you wouldn't you can effectively just write a semantic garbage collector. So if you have a import statement or even just any AST node with no edges leaving it to anything else, then you know you can look for it and try and cull it. Whereas if you try and kind of specifically start with importing things and then work backwards to what you need, basically just going to get stuck in. It's partly DMD hell, but also just compiler hell, because it's not a sort of traditional thing you can do with an AST. There isn't really a question there, I'm afraid.
Yes.
All right, we can squeeze in one more question if you've got it. Going once, going twice, nothing. All right, that's it. Thank you, Razvan. All right, before we get off to the lunch break, there is something we need to let everybody know about, and that is lightning talks. So if you've not been here before, what we do every year is we crowdsource a bunch of 5-minute talks from the audience here. This will take place on Thursday. If you have 5 minutes that you want to talk about, what you need to do is you need to approach Mike there. He's up the back wearing the hat and waving at everybody. So say hello, he's a friendly fella, and he'll just slot you in there. We have 8 slots remaining from 9 total. So yeah, surely there's 8 talks we got here. We always fill them up, so by all means, approach Mike whenever you think you've got to talk, and then just get to writing your slides. I think that's all the housekeeping we need to do. Nothing else, man? Yeah. All right, lunchtime. Hey, everybody. Yeah, we're not quite ready to start yet, but we will be keeping the schedule on track. It turns out that this fella right here did not take any of the speakers' laptops, right? So we're actually good for the rest of the event. Sucks that it actually happened, but check it out. This here, we got a professional. This guy's done it before. He's come in with a business jacket. He's got something that looks like a lanyard hidden inside. Speaking on the phone, just scoping out the place, making sure nobody is looking, and then let's hit play. This is the fate of Ian's laptop. Whoop, there he goes. Yeah. I think that's a pretty good lesson in security for us all. You know, we all have a little bit of interest in cybersecurity, but that is real world. This is how hacks start, for example. A little bit of social engineering. That guy dressed up for the occasion, got in undetected, took a few laptops undetected. So, yeah. Woo. Anyway, now that that's out of the way, we've got about 5 minutes left before we kick off. So please continue milling. Try and relax. Yeah, we'll get back to the program. What's your thing here? It was roughly an hour ago from the live.
But we've got all of the info, so I think they might be coming around.
Yeah. It's just record keeping at this point. The laptops are gone. He won't be found. Did that. There it goes. Nope. Wake up. Somebody was like, well, you know, we could put, why was this guy able to do this? And I'm like, well, there's a very simple reason. We publish when we're not in the building. Right. So needless to say, tomorrow I'm not having lunch with everybody else. It's not going to happen again. It's not going to happen again. It's going to hit it one and done. But I'm still going to pay attention. You know, so. the travel lodge.
City Road. They're going to recommend tab at the bar.
All right, we're back from lunch. We all having fun? Yeah? Yeah, come on, heavy, joy, nothing was solid, everything's fine, let's move on with it, okay? Okay, let's go. We all know, Dennis, you've done DConf talks before, right?
Yeah, last year was my first one.
Exactly, just got to check these things, because we like giving our new DConf speakers support, but you've done it before, so whatever, man.
Not nervous at all right now.
Before we do, though, let's talk a little bit of logistics for later on today, because we all know the reason everybody comes here is BeerConf, right? So we're all set up at the Travel Lodge just up the road there this year. Tonight, it's going to be pay for your own beer. Okay, tomorrow, we have HREF will be paying for some beer. So, woo, come get your free beers. Yeah. All right, I think that's all we need to do for the bookkeeping. So tell us all about stack memory.
Thank you.
Applause, come on, programmer energy.
All right. I'm going to talk about why stack memory is awesome. Last year, I introduced myself extensively. I'm not going to do that again, but it came down to I tried a bunch of languages for my studies, and they had their strengths, but I ended up with D because it's a jack of all trades, and I can use it for both high level and low level without the friction of interfacing between languages. In this talk, I'm going to talk about memory. I'll explain the difference between global, stack, and heap memory, what makes stack memory so great, how DIP1000 makes using stack memory safe, and some problems and future work of DIP1000. So as a justification for why DIP1000 even exists, memory speed matters because even though my desktop has 32 gigabytes of RAM, only about 192 kilobytes is fast, meaning is L1 cache close to the processor, and the access time of cached memory versus other memory is huge. It's 1 nanosecond versus 100 nanoseconds. And so performance of modern programs is often memory bound. I've had programs where I was fiddling with compiler flags, trying to see, is this function getting inlined? And it didn't make a dent, but reducing the size of a lookup table cut the runtime in half. Why memory safety matters? Well, we're deprogrammers. We know that by now. Memory corruption bugs are common in unprotected languages, hard to debug, wreaking havoc. They can cause arbitrary code execution if you're unlucky, and just generally expensive. Now, a bit of a warning about this talk. This might all be moot, because right after this talk, Robert is going to argue why we can make D memory safe by reducing features instead of adding features, as DIP 1000 does. So this is either going to be a useful tutorial or a eulogy for DIP 1000. So let's start with different types of memory. Global memory is basically everything that you see when you look at the output of an assembler. I have a function here, and on the right-hand side, it shows the assembly. The instructions get put into global memory. String literal I use gets put into global memory. Global variables or variables annotated with static are also put in global memory. It must be all known up front. It is stored uncompressed in the executable. Zero data does not get stored as an array of 0 bytes. There, it does just store the length, but otherwise, the array is put in the executable directly. And the operating system loads the executable into RAM when it starts and unloads it when it exits. So it's available throughout the entire runtime. Stack memory is used for function local variables, which are also known up front. But they can't be global because of recursion. A function might end up calling itself again, and then multiple copies of the same local variable need to be stored. So how this works is the OS initializes a region. The size is by default 1 megabyte on Windows and 8 megabytes on Linux, but you can change it with the right linker flags. And this region is used as follows. Here I have a code example of a simple recursive factorial. We're currently in main, which has a stack frame on the stack with all the local variables that exist in that function. And when we call factorial, it stores a pointer to the previous stack frame and pushes the local variables for it on the stack. And when you recursively call the function, it stacks more and more stack frames, which is why it's called stack memory. And then as you return, those stack frames get popped. And then when we go to the next statement in main, write line, it creates a stack frame for that, and the memory we just used for factorial is now used for write line. At the top of a stack, there's a guard page, which prevents the stack from growing past the 1 or 8 megabytes it is and corrupting other memory. This is a page where every time you read from it or write to it, the operating system issues a segfault. The assembly of our factorial function looks like this. At the start, it pushes the frame pointer and subtracts the stack pointer, and that's how stack allocation works. It's just subtracting an integer. Adding more stack variables to your function doesn't add any time. It just subtracts a larger integer. And at the end, before returning, it adds it back and pops the frame pointer again. So it has little overhead. Heap memory, on the other hand, is more complex. It's dynamically allocated at runtime, and the OS provides base functions for expanding and shrinking the heap. And it's often accessed using the C library, which provides malloc and free. In D, we use it through the garbage collector, which is built on top of malloc and free. Operations that invoke the garbage collector and thus allocate on the heap are the new operator, array literals, setting the array length, and concatenating. All pretty simple stuff. So the algorithm to manage the blocks of heap memory is more complex than the stack, because apart from allocating consistently, at any point a programmer might ask to free blocks from the middle of it, and then allocate new blocks and deallocate more blocks. It doesn't just shrink and grow from one end. So there's always research going on to find a better algorithm for efficiently managing a heap. So now we've covered all three. Which type of memory is the best? It's a bit of a trick question, actually. Best is no memory allocation, because often allocation isn't needed in the first place. Like a common example is splitting a string into words and then storing it in an array, only to iterate over the array once, which can also be done lazily with a splitter, which is also provided by Phobos. And then you don't need to stack or heap allocate an array. But when you have to allocate memory, static data works well with global memory. You can use it as long as it fits by using array literals, string literals, or a string import statement which loads a file into global memory. But it's not that great for large or compressed files. When you have a game with large assets, you don't want to load all of them at the same time, because you don't need them all at the same time, and there might not be enough room for all of them. So then you can dynamically read the file at runtime. Now, for dynamic data, what kind of memory is best for that? Please don't use global mutable memory. Global variables make your program hard to test, really complex to reason about, and not easy to multi-thread, which leaves heap and stack memory. So which one is best? Well, you've seen the title of the talk, right? So yeah, stack is way more lightweight and simple. So it's preferable to use stack memory. But sometimes it is, you can't always use stack memory, otherwise heap memory wouldn't exist, of course. So the limitations of pancakes are limited size. We only have our few megabytes region. We can't put too large files on the stack or it will overflow. And also, putting large things on the stack will reduce the cache friendliness of the stack. Here are the default sizes again. You also need to know the size of what you want to allocate upfront, or you need to have an upper bound. And if you put that too high, then you waste a bunch of stack space, which might be bad for cache. You can dynamically allocate on the stack with alloc A, but that's not recommended for various reasons, which I won't go over right now. Stack memory has a limited lifetime. You cannot return stack memory if I have a static array allocated here and return a slice to it. That slice will point to a stack frame that's popped after the return statement, so it's a dangling pointer. So how can we use stack memory more? Here I have a typical example of creating a string at runtime, just to draw it. So this might be from your game. And we're using format to combine name colon with actual name and pass it to our draw text function. Format returns a GC allocated string, and every time you call it, for every call site. And this alone at 60 FPS creates 172 kilobytes of garbage every minute your game runs, which might not seem like a lot with 32 gigabytes of RAM in total, but remember, fast memory is at a premium still, and you can multiply this by the amount of times you needlessly make small heap allocations. So how would we do it in C? C is fast, right? So let's take a look. Typically, you would allocate, reserve a buffer on the stack as a static array, void initialize it because you won't use most of it, so you don't want to waste time initializing all of it. Then with the sn printf function, we concatenate and build our string, and then we pass it to our draw text function. This is faster but uglier code. We now need 3 lines for what used to be 1. And is it even memory safe? We pass our buff pointer to this message parameter, and we don't know what draw text does with it. It might store it in a global variable and actually draw it later. And then it would be a dangling pointer as soon as draw name tag returns. So in C, what you have to do, if you're lucky, check the documentation for pointer lifetimes. Here I have an example of a C function which, with good documentation, which has a pointer lifetime section saying the specified string is copied before this function returns. In other words, we're good. We can pass stack memory to it. But it would be nice if there was a unified way to signal this property that the compiler even understands, so it can be verified automatically. And this is where dip1000 comes in. Dip1000 is, by the way, not the best, most marketable name. I would call it maybe something more catchy like stack don't crack 64. But for now, I'm just going to keep calling it dip1000. So it adds the scope storage class. Well, it doesn't technically add it. It has been there in the language before, but it starts actually using it and verifying it. So when you annotate a variable scope, it means that it holds something that may not escape the current block that the variable is in. And taking the address of a variable becomes now allowed. And this will infer scope on the variable that takes the address of a local variable. So I've written scope here explicitly, but it's optional. The compiler will infer scope if you take the address of a local and give the same error all the same. So the general rule that dip1000 maintains is for every assignment of variables which have pointers, the VA may not have a longer lifetime than V. So what are these things in quotation marks I refer to? So an assignment is usually just an expression with the equals operator, but there are other forms that are implicitly assigning one variable to another. A return statement assigns it to a variable up the call stack. When you pass it to a function, it assigns it to a parameter. And when you put it in an array literal, it assigns it on the heap. Whether something has pointers, a pointer is obviously a pointer. A slice internally is a pointer and a length. And a class is a pointer to a class instance. Basic types or static arrays and structs with basic types don't have pointers. But if you give them a type with pointers as a base type, then the whole thing will have pointers. And const and immutable shared type constructors don't matter for whether a type has pointers. So variables, the thing about assignments is they're not always directly between variables. We can have, it's between two expressions, which may include operators. But what the compiler tries to do is see through all the operators and look at which variable are really there. So slicing a pointer will still result in the same pointer variable. Looking at a struct field will result in just the struct variable being considered. And some expressions may even escape or refer to multiple variables, like the ternary operator. The lifetime is, well, a global variable has longer lifetime than scope variables, obviously. But between scope variables, there's also a lifetime, which is the order they appear in the source code. And this error is important because of destructors. If you destructors are run in the reverse order. So when you destruct S1, you don't want S0 to still have a reference to S1, which it could still read in its own destructor and then read a dangling pointer. So in short, DIP1000 cares about variables, whether it has pointers and assignments between variables, and not about the exact type expressions or control flow. And this is basically a pseudocode implementation just to show that there's nothing super complicated going on, like complicated algorithms. It's just going over each assignment and checking, comparing lifetimes. So parameters can also be annotated return scope, which is like the in-out of lifetime. It means if I put a scope variable in, I won't escape it by assigning to a global variable, but I may still return it, so the compiler keeps track of it. And if you don't put a scope variable in, then the return value won't be a scope variable either. Return ref applies to ref parameters, which are internally passed by pointer, but from a high-level point of view, they're not actually pointer types. If I add scope to a ref int, it doesn't do anything, because int doesn't have pointers, so it will just be ignored. And ref has, in a way, scope built in, because when I take the address of a ref parameter, I cannot assign it to a global variable, because the ref parameter, there's no restriction to what you pass it to, so it might be a local variable, which may not be escaped to a global variable. So with return ref, you can return the address of the parameter, and it's similar to return scope. But here the rule is when you have a local variable in, you get a scope value out. So not just scope local variables, all local variables. And here's an example of that. Local isn't scope. It couldn't even be scope because it's just an integer. But when you take the address of it, the resulting pointer will still be scope. So this is an overview of the parameter storage classes. The syntax is often confusing with return ref and return scope, but it basically comes down to what am I doing with the parameter? Am I taking the address, returning the identity, or only reading it? This does get a bit tricky with arrays, though, because static arrays and dynamic arrays have similar operations, but notice how they are in different rows, because when you index a dynamic array, this will dereference the pointer, and when you slice it, it returns. It's an identity operation, while for a static array, indexing is an identity operation, and slicing it will take the address of a static array. So how do return scope and return ref apply to member functions? A member function implicitly accesses the variable through a hidden parameter called this, which is not specified in the parameter list, but if we turn it into a free function, it would look like this, and the struct instance is passed by ref. Now, if we would like to add const to the this parameter, we would add it as for a member function, we would put the const behind the parameter list. And the same applies to return ref. If you want return ref to apply to a member function, then it also gets put behind the parameter list, which does look a bit silly having a return keyword right there. And in fact, last year in my Lightning talk, I made fun of that by compiling this obfuscated example. But yeah, that's how it works. So we'll stick with it for now. So going back to our example in C, how do we make this more tidy and safe? We can do this by defining a struct and putting the buffer in there, specifying a length and a function to slice the right amount of that buffer, and add alias this to implicitly convert it to it. Then add a function which void initializes such a stack, such a struct. By the way, you can't put void in the struct itself. I mean, you can do it, but it will still zero initialize it currently. And then we concatenate the strings with slice operations and return the struct. And with named return value optimization, it will be put on the caller's stack. And then we can just use it like this, which is a lot nicer. But is it safe? We're still passing a address to stack memory to our draw text function, which we did annotate with scope. But does the compiler know that it has to be scope? If we remove scope from draw text, will it fail to compile? Well, if we look at our toSlice function, we need to tell that when the stack string you call this on is a local variable, the return value, the char array, should be a scope value. So which annotation are we going to use for that? Well, if we look at the compiler error output, it says it escapes a reference to parameter this, and it says perhaps annotate the function with return. So we use return and not return scope, because return scope doesn't apply here. The stack string doesn't have any pointer members. But this is actually a trick question again. We don't annotate it with return. We use inference. It's way better to let the compiler infer the right return annotation. And in auto-return, nested or template functions, scope, return scope, and return ref are inferred, just like other function attributes. And a further improvement we could add to our stack string is use malloc for larger sizes, which exceed our buffer, and then call free in the destructor. And I don't have time to show that all on one slide, but there's an example of that in Phobos, temp C string, which is used to convert a slice to a C string using stack memory for small strings. And DMD uses internally the small buffer structure. Unfortunately, there is not a generic reusable public stack allocator like this in Phobos, as far as I know, but that would be a nice improvement. So gotchas. TIP 1000 is known to be confusing. One of the reasons is the scope transitivity rule. Scope is a variable storage class, not a type constructor, and it only applies to the first indirection of a variable's type. So you cannot take the address of a scope variable, which catches many people by surprise. They try to maybe add another scope in parentheses, but that's not how it works, unfortunately. And also, when you dereference a scope pointer, the result, even if it's still a pointer, will not be scope anymore. And as a result of this, scope doesn't work that great with classes, because for classes, their member functions pass the class instance by pointer, not by ref. So you cannot store a scope value in a class, because scope applies to the class instance, not the members. So you can only use scope to safely stack allocate a class in the Node.js code, but you can't store scope variables in that instance, at least not in safe code. For it to be safe, class constructors and member functions need to be scope, which they are in practice, but they're often not annotated as such. A typical constructor like this still needs to be annotated safe scope, even though it is pretty obvious. So that is a source of friction with using classes and scope. And then there's, of course, our favorite return ref scope ambiguity. A variable can be both ref and return scope, or both return ref and scope. And as you notice, these are the exact same three keywords. So how does the compiler distinguish the two? By the order. And the order return scope is always recognized. When you first have return and scope, it's recognized as return scope, and other orders will result in return ref. And this looks particularly weird on member functions where you have no ref in addition to the other keywords. So yeah, scope return means something else than return scope, but again, if we make this a template function, it will be inferred, and we don't have to look at that mess. So while DIP 1000 is very confusing sometimes, you see that the underlying ideas are pretty simple. And so if you look at the issue list and search for DIP 1000 issues, you get 146 issues? What happened here? So a bit of a history of the development of DIP 1000. In 2015, DIP 25 introduced return ref, and it got implemented. And in 2016, DIP 1000 was born and accepted. But it's superseded. It's outdated now. The things it says are no longer true, like you cannot attach a scope to a return value. That doesn't work anymore. And it's superseded by the implementation, because as you implement things, you might find new, better ways to do things, and so it started to deviate from the specification. On top of that, DIP 1000 is actually a breaking change, which is weird, because taking the address of locals wasn't safe before, and now it is. It should add more code and not reduce the amount of valid code. But there was a big bug in safe. While taking the address of using a pointer was not allowed in safe code before DIP 1000, slicing a static array would just pass, and the compiler would give no lifetime restrictions on it. And much existing code relied on this fact. So in order to reduce breakage and give time to transition, a transition flag was made and renamed DIP 1000, and it's now consolidated with the other preview flags. So is the switch ready to use for programmers? Well, it wasn't at the start because there are linking issues. Phobos is pre-compiled without DIP 1000, and scope is part of a mangle, and a mangle is an encoding of a function name, including the return types and parameter types, which will be used for linking and overloading. With DIP 1000, scope would be inferred, and a little m would be added to the mangle, and without DIP 1000, it wouldn't. So linking DIP 1000 code with non-DIP 1000 code would give issues. But this was solved by making inferred scope not part of the mangle anymore. We're now in the year 2017. In 2018, an extension was added. So unlike the regular return scope that returns to the return value, a special rule was added that if the function returns void, then return scope wouldn't make sense, but you can make it return by assigning to the first ref parameter, and then the lifetime would be transferred to that, which seems like a weirdly specific edge case, but it was because Phobos had a common pattern of assigning parameters to a struct through a constructor or op-assign method. And in this case, you want to be able to assign a scope variable and make the resulting struct scope. And since struct member functions have a hidden first ref parameter for this, that's why the first parameter rule was added. This way, no new syntax was needed. But it was a bit confusing. So yeah, with return scope, this is now allowed to assign stack variables. But at this point, Walter was the only person in the world understanding DIP 1000. So this pull request sparked a big discussion because other contributors were begging for documentation. What is going on? Why are we adding this? This wasn't in the original DIP document. But eventually, it got sorted out. And as of 2019, Phobos finally compiles with preview equals DIP 1000. In DConf Online 2020, Matthias asked, do you have a question?
No, I was just going to comment that it was trivially obvious to the most casual observer that
yeah, the opinions differ on that front. So in DConf Online 2020, Matthias asked, is there a plan to enable DIP 1000 by default, and what's the timeline? It's been like 4 years now. And Walter said, oh, we could do it now, and added, well, the spec needs to be finished, because documentation was still kind of lacking. And Attila added, we need to turn on warnings for DIP 1000 violations, because people don't use the switch, and they need to be kind of reminded, like, hey, update your code. And in 2021, this is where my involvement came in. So one day, I was writing safe, pure DIP 1000 code, like a good boy. And I got memory corruption, despite safe and DIP 1000, because the compiler wrongly stack allocated an array literal. So the compiler has this little shortcut where even if there's no scope annotation on this character array parameter, it says, well, it must be scope because the function is pure. There are simply no global variables or other parameters to escape to. But it didn't take into account the return value. So even when you returned the parameter, it was like, yeah, that's scope. And so when you call it with an array literal, well, the array literal won't escape G, so I can stack allocate this. And then when you return it, you return a dangling stack pointer. So I posted about this on the forums and started fixing it. It turned out a lot of code relied on this bug. And so I went down the rabbit hole and fixed a bunch of phobos, and also uncovered more and more issues about the implementation of DIP 1000, which I also posted about. But I got to work on fixing those, and by 2022, I made DIP 1000 errors consistent, and deprecation warnings for DIP 1000 were now enabled, which was what Attila wanted. So with preview equals DIP 1000, scope violations would result in an error or the function inferring system. In system code, lifetime checking is not is permitted. And in default, without any compiler switch, it would warn in safe code and in inferred functions. It wouldn't infer system, but when you call that function from a safe function, which has a DIP 1000 violation in it, it would warn about it then. So basically, it would print every error you would get if you were to actually switch to DIP 1000, but as deprecation warnings. And as of a few months ago, they're now disabled again, because it turns out the transition is still not very smooth. Some projects have a litany of warnings that are hard to fix, and there's still some work to do to make the transition a bit better. So what were some of these past issues that I ended up fixing? The initial implementation for checking if one scope variable was declared earlier than another scope variable was with a global variable incremented in the constructor of variable declarations. The assumption here being that the compiler would, in any case, create variable declarations in the order that they appear in the source file. So is that the case? No. Parameters are created later than local variables, even when they are earlier in the source file. So an extra check was added for parameters, and before you know it, it grew into this mess, which also took into account temporary variables for each variables. And it had a fallback, which looked at the line number and column number of the variable. And so I managed to fix this and reduce it back to just one simple comparison by incrementing the sequence number later, not in the constructor, but just before semantic analysis of the variable, which is not like the greatest, but it's a lot better than what it was before. Another common issue is code duplication. Here you see the code from both the caller and callee perspective, which checks if extended return scope semantics apply. So whether you can return by assigning to the first variable. And it's supposed to be the same. If one of these deviates from the other, then the compiler allows memory corrupting code, which is bad. So I refactored this into one consistent function So both the caller and callee use the same logic. And not just between caller and callee there is code duplication. The compiler internally doesn't put this parameter in the array with the other parameters, so it always has to be checked separately, which causes duplication. Escape by value and reference are very similar, but completely duplicated. The different ways of assignment are also duplicated. So what often would happen is there would be an overfitted bug fix, where someone files a Bugzilla issue, and then Walter would open a pull request which fixes only the issue's code snippet. And I would ask, what about the other cases? You fixed it for normal parameters, but it's still broken for this parameter. And then the response would be, that's a separate issue. So open a new Bugzilla issue. And so that's often what happened. For example, with the return ref scope ambiguity, even the compiler was confused at some point about the whole ref return scope thing. So there were tons of bugs with that. And Walter would repeatedly say, it's fixed now. And I would say, no, it's not. It's fixed here, but in these other copies of the code, it's still doing the old thing. And there would be pull request after pull request after pull request trying to like, oh, is it fixed now? Is it fixed now? Until eventually it basically is. And this culminated also in this nice post by Timon. Timon has emailed his frustrations about DIP 1000 and also mentioned in his talk how with tuples the scope lifetimes would be conflated. And Walter would often defend DIP 1000's soundness by saying, well, all Bugzilla issues I saw were fixable. But Adam succinctly put it as, well, yeah, you can put it in Bugzilla, but the fix will probably be if code equals that, error, nice try, Timon. Which would close the issue, but doesn't, it's like plugging holes in an infinite cheese grater, I think was the analogy that was being used. So some of the issues that still persist to this day are the scope inference, which isn't very great. So how it works is basically, at the start of function analysis, parameters are flagged. They may be scope, and every time you do something, like take the address of it or assign it to a non-scope variable, the flag would be taken away. It's not maybe scope. When you return the variable or a reference to the variable, it would infer return ref or return scope. And at the end of function analysis, all the variables that survived and still got their maybe scope flag are turned into scope. So this is killed very easily by assignment to temporaries. If I have a variable parameter p, which may be scope, and I assign it to a variable which is not explicitly marked scope, the compiler gives up and says, yeah, p may not be scope anymore, even though p2 isn't ever escaped. Also, when you assign a scope parameter to another parameter and then return that parameter, it will infer return on R, but not on P, which is where it's got its pointer from. So there's missing return scope inference on P, which is also not sound. I started a pull request to improve this, which would, when you assign two variables, kind of create a link between P and R that says, oh, if you return one, the other must be returned as well. But it's, the code is quite complex, and it's blocked currently, so there's still work to do to make that work with all the existing complexity. This is the issue that Timon talked about, reduced a bit, where nested functions, they access scope, can return scope variables from outside their own scope. And implicitly, this, like internally, this happens by looking at going through the hidden this parameter, which encloses the enclosing function. But DIP 1000, unlike with structs, where early on it rewrites outer access to this dot s, with nested functions, it's a bit more complicated, so still work to do there. I've also started working on that, which also has its own issues. mangled names. So remember how inferred scope was ignored in mangles? Well, guess how the compiler internally compares types for equality? By their mangle. So this causes some internal inconsistencies where it thinks two functions where one has inferred scope and one has no scope are exactly the same when they aren't. So the solution is to have the same scope inference with or without DIP1000 and then include inferred scope in the mangle, which is also work in progress and breaks other code. So apart from issues with the implementation, there are also some limitations in its design. So we've already seen that scope is not precise. It applies to a single pointer object and not individual struct members, so the lifetimes get conflated. There's only one level of indirection. Also, it doesn't support resizing memory. So Attila made an attempt with AutoMem to create a vector type which you can dynamically expand and shrink without the garbage collector, and you can slice it to borrow. You can use the slice operator to borrow a view of it, but then when you call reserve or resize the vector, then this should invalidate the borrowed slice, but it doesn't, so that would return result in a dangling pointer. Now the successor to DIP1000, DIP1021 and Live, attempt to add an ownership and borrowing system, but they're not sound. Manually freeing or resizing memory is still system, and they don't enable any new safe or trusted code, so it's basically a bad deal right now. So some final notes. General lessons I got from fixing those bugs were, well, some obvious ones: tests and documentation good, code duplication bad. Also, it's important to find the root cause of the Bugzilla issue and not just fight the symptoms, or else the Bugzilla issue will just come back, and your code will only get more complex while not moving to a better code base. So it's important to fix the unstable foundation. I really liked the bug fixes where the diff was completely red. I could remove all the clutch because the base was fixed, instead of the bug fixes which added more if statements for the Bugzilla issues. And reject valid bugs are better than accept invalid bugs. So a common theme was that DIP1000 would be too lenient, and then the existing code would rely on the bugs, and then when you fix it, it breaks code and it slows down the improvements. So my final verdict about DIP1000. In general, for memory, if you want high-performance code, prefer no allocation or stack allocation over heap memory. DIP1000 is a nice, simple idea, but unfortunately has some complex execution by the way it's implemented, and also the syntax with the keywords is a bit unfortunate with the scope return and return scope confusion. And it works best with flat data, because scope is not transitive, which personally I haven't found to be that bad, because when I write high-performance code, often it's useful to convert your data structures into flat data anyway, because even when you're not accommodating for the limitations of scope, it's a useful thing to do to make your memory more cache-friendly or GPU-friendly. And that closes my presentation.
All right, so it's a question time. Attila's got one down the front. And again, I am looking at Discord and YouTube.
Two statements and one question. First of all, I think that's the first time I understood return scope ever, so thank you for that, and also well done. Two, you said that there wasn't any allocator in Phobos that did the stack thing. There is. You can use a fallback allocator with in situ and then whatever you want afterwards, mallocator GC. And the question is, if you go back to that sequence number bug that you fixed,
see. Where was it? Yeah, which one?
Yeah, so that. Won't this break with separate compilation? Because the number won't be incremented the same way?
No, because the sequence number is only used within a function. So it's not that there's two functions and the sequence number in one function are compared with the other. It's only when you analyze a function that the sequence numbers are used, and you cannot separately compile the first half of a function and the second half. So.
All right, good, thanks.
I also want to compliment you, Dennis, on doing a very difficult job with this. I appreciate it. Not many people have been able to do the kind of work you do with this, so thank you.
Thanks.
More questions. Come on, I know you've got them. Stick your hand up. There we go.
So one thing I think we could use in the maybe scope flag or whatever that is something to say, definitely don't want this variable to be scope. Because a lot of times you declare it and you say, how did this thing become scope? Because I wasn't intending it, but it just happened to be where it got assigned first or whatever.
Like for a parameter or a local variable?
Local variable. To be able to say, this local variable, I want to make sure it's scope.
Yeah, there is a trick you can do where you take the address of it, cast the pointer to an integer, and then cast it back, and then it loses the whole scope thing, but it's kind of a hack.
Nice to see something else.
Yeah.
Any more questions? No? Really? Even the amount of conversation around DIP 1000.
I explained it so well, all the confusion is now out of the world.
You've really got nothing to say now. Jeez. All right, let's call it then. Give it up. Oh, wait, one more. Slow down.
Sorry, guys. So to continue on what Steven said, in DIP 1000, you have this weird behavior where you can declare a variable, let's say a pointer to int, and then later on you do something and it turns it into a scope. What's your take on that?
Like what Steven said, that sometimes scope is inferred when you don't want it?
Yeah, other attribute like static or immutable, you declare it at the variable declaration point, but in DIP 1000 it can just gain scope a few hundred lines down.
I mean, like I would prefer to not add anything, and just unless there's really compelling use cases, I would have to see some specific examples and see if really there's not just a nice workaround. Because personally, I haven't found the need very often to cast away scope. Usually I just use a trusted function annotated with return scope or scope. If like the checking has a bug, then I just add trusted to a small piece of code which should be allowed, and then that works.
The easiest way to make it inferred as not scope is assign it to a static variable.
Yeah, but
it's super easy, and you don't have to ever read the value from the static variable. You just assign it, and I'll go, oh, I can't make this scope.
Yeah, that's a bit ugly because then it generates a pointless static variable. It just
right, but
I mean it's only 4 bytes or 8 bytes, but still, it's kind of ugly.
No, yeah, but it doesn't involve any new features or anything.
Yeah, okay.
New features mean more bugs, so
I suspect you could create a global static array of 0 size and assign to its first member inside an if false, and then you won't have any litter.
What?
I mean, you can do that, but the issue here with what Matthias is saying is basically that it does the beginning bit of some data flow analysis and then stops. So the fact that it changes is you can get used to that, but it's more that if you do something that means if you had a full data flow analysis pass, it would be considered not scope again. It doesn't actually, if you think about it inductively while programming, it doesn't actually do what you might expect it to.
Yeah, so you're relying on the limitations of the inference, which is not a great idea, right?
Yes.
Yeah. Because they might be improved later, and then it breaks. You know.
So it's just one more rule.
All right, I think that's that then. All right, now you can give it up. All right, you'll know the drill. We have 6 minutes until we kick off the next talk, so enjoy.
Yeah.
Yeah, I'm not leaving this room, so you don't need to worry. If I see somebody stealing your laptops, they're not going to enjoy the experience. All right.
That's the.
It's a display
program. I don't have display part. Good start.
or no, it's a Thunderbolt.
Awesome talk.
Thanks.
Hey, everybody, we're back on. Come on. It's cool. Your laptops are still here. You don't need to worry.
Yeah, fair enough.
I said I wasn't going to make a laptop joke, but I'm Australian. I had to. Come on. All right, I keep on trying to use the Walter metric as to when we should start here. It's like when Walter sits down, we're good, but Walter's disappeared again. So let's just kick it off. You ready to go?
Sure.
Talking to us about invalidating Dennis's talk. This should be fun.
Let's see.
Let's see. All right, everybody, give it up for Robert.
First of all, thanks for having me. This is the title, but there was actually a subtitle to it, which I cut, but then thought maybe I should put it back in to sort of set the mood. So that's the title, and that's the subtitle. And like if you have tomatoes or stones, please wait till the end. But then let's see what's happening. So D, boiler code free code. What's actually happening? What is this? This is not boiler code, that's not boiler free code. Like return ref, what is actually going on here? This is not nice, I don't want this. Like Attila earlier said that he understood what return ref was doing. I'm still not there. And I'm sort of your average user here, so no. Just from the syntax, it's too much. Like I don't want to deal with this, and I bet many people also will not want to deal with this. And then Dennis told us many things that are to come, bug fixes, issues still existing, and we're not done. And so one of the things I think is actually happening here is actually not, like div 1000 is not the problem. I think the problem is that we think that D is the successor to C and C++. And that is not true. That battle is over. Rust has won. We don't have to fight that fight. It's not our fight, it's over. Like Rust has won. But there's still enough space for D to live and to live great and have like a long-lasting thing that when we're all 70 or older, we can still come to DConf and talk to each other how great the 2020 was. So, and also, we think that safe languages or memory-safe languages are a new thing. They are not. Most languages are memory-safe. Take Python, take JavaScript, take Java. They're all memory-safe. We are not doing something new here. Rust is not doing something new here. It's all boring and already exists. And to maybe get the point across a bit better, I think this will happen in a few years' time. And then, well, this is where we are going to be. But nobody's going to care. It's Rust, and we are actually second place already. Why do we have to do something else? And obviously, we have done quite a few things, and I'm going to maybe sort of give a different perspective on how we can actually live in this space and have everything we wanted, and also have stack memory, because stack memory is awesome. And Dennis is right. Like if you can't do global, do stack. So luckily, at this point, there's still some people around here, so I can continue without talking to myself in the empty room, which is a really good start. So let's have a look. Again, what is this? All those rules, I still don't get it. Why do I have to care? I just want to get my job done and actually understand the problem that I should solve with the programming language as a tool. Like, I don't care about the memory. It just shouldn't break. So let's take a step back and think about this. DIP 1000, DIP 1021, I think was the number, DIP 1035, all those things add syntax and semantics to the language. But what if we remove some stuff and take a different perspective? So let's just say we take old school safe, and then we make the unary AND operator an error. We remove that from the grammar. So you can't take the address of the stack. And also, we disallow returning via ref. And also, we don't allow to slice static arrays. Let's see what happens. So what I think are the consequences of those choices is we don't need DIP 1000 and all that to get workable, safe D. So at safe, at the old standard. Also, we get quite a few other things. One negative thing might be we won't get user-defined safe containers that behave like built-in types like an array or an associative array. Also, there's going to be no manual memory management in safe code anymore, which I think is fine because the stack, for most part, is perfect. Also, what probably most of you forgot, we're going to get a clear definition of property because there's some interesting tidbits in there where, stuff behaves differently when you take the address. And a few other things which we can't get into because, I only have 45 minutes. So let's see what the consequences are in practice and what we maybe can do to remedy those. One of the things that quite often you do is you have some local v in this case. You take the address, pass it to a function, and then you have to do some dip 1000 stuff and annotate that. Yes? Absolutely. Thank you. Thank you, Ali. So how can we actually work against this? Well, quite simple. D already has everything we need. Instead of passing a pointer, pass a ref. And we don't even have to take the address. The assembly at the end will be the same. The optimizer will do the same. And we don't have to add anything to the language. And it's safe, and you can do it right now. You don't get any application messages. You don't have to code. It's easy. And other things, if you want to pass data up, we actually, so the old style is you pass the pointer in, you again have to do scope, but we have an out keyword. You can just do this, and it's obvious to even the novice what is going on there. You just return the data, you don't have to take the address, it's obvious what's happening. And so for containers, everybody wants user-defined containers that do manual memory management, that behave like built-ins. But even D can't do that. This is a hack in the compiler, like turning a const int array into an array of const int. This works in D, but it's pretty much a hack in the compiler. So we are asking for something that D itself can't really do. Maybe we shouldn't ask for it or realize that we're not going to get it. But that's not a problem because there are remedies to this to make code easy and understandable. So let's say we want to build our own container that stores data. So this one here is quite simple. We have like an array struct that has a static array inside to actually store the data. What you would normally do is on op index, you return a ref to the element. Fair enough. But then you can have a situation like this, where you have a main function that calls a function that has that container that's living on the stack, and we return a ref from the function and then take the address of it. The stack, as Dennis illustrated so nicely, has gone away, and we are in a situation where we have non-memory safe code. But as I said earlier, what if we disallow returning by ref? What would you do? What would you do instead? So one possibility, instead of using op index, you have a function called get. You pass in the index, and you pass in the out parameter to do the thing. And here already you can see the new code, even though a bit cut up at the bottom, is safe. A is going to be fine, even after fun returns. So quite simple again. Instead of returning, we pass the memory into which we want to write via function parameter. But still, this code is not quite perfect. You could still be out of bounds, and we're going to get to that a bit later as well. So an even nicer thing to do is we have a nullable type in the standard library. So what if we pass that in and then check if our index is still in the bounds, and if that is the case, we actually write into the nullable, meaning that by the time we get back to main or after line 25 here, we can actually check if there is a value in the nullable. This is perfectly fine. There's no way this is going to leak, except maybe that nullable is doing something very crazy, but then I guess we as developers of the language and library have screwed this one up ourselves at some point in the past. But it's there already. We don't need new syntax to do this. And even the newest of novices will quite easily understand what is going on here and doesn't have to listen to a very well made presentation of 100 whatnot slides to do what scope, ref, dip, whatever does.
it's there already. Why make it more complicated? So this is a nice thing that I sort of got to while working on this. Show of hands. What is the type of pointer here? Is it a pointer to the property function, or is it a pointer to the property function? Is it a pointer to the value returned by the property function? Yeah, I think somebody raised their hands twice. Actually, I think you're all wrong. This should be a syntax error. You're not allowed to take the address, period. That is a message a novice will understand, or I will understand if I'm tired. You can't. It's a syntax error. Very easy. Another example. Let's not be smart. I sort of tried to test here that it's actually returning into a name parameter, but what happened when I passed this to LDC and enabled optimization, like the whole function fun disappeared, uniform disappeared. All it did was basically filling up the array in the main function with SIMD code and making it really quick. Like if I started fiddling around with passing the data via a pointer or ref into this, like I'm quite sure at some point the LDC optimizer would have said, I'm not sure what you're doing here, it seems sketchy, I'm just going to opt out and do sort of the boring code generation. Make it simple, make it easy. Who remembers this guy? Okay, so for the younger people around you, this is Scott Myers, and him, Andre Alexandrescu and Herb Sutter, those are basically the C++ gods. They told us for decades how to do C++. And he gave a very interesting presentation in 2014. Anybody remembered what he said in the end, the last sentence? Ali?
The last thing D needs is a person like me.
Exactly. The last thing D needs is a person like him. And I would argue that person for DIP 1000, that's Dennis. And that's just one part of the language. We haven't talked about templates yet and all the other stuff. And I think he is still right. And this has been nearly 10 years ago when he said it. And we are going down that route quickly. And yeah, well, maybe Dennis wants to be that person, then he's doing a great job. But I think he wants to do other stuff as well. So maybe let's not go down that route. And coming from that, there are other things that we have done that makes the language difficult to get into, difficult to reason about at scale, and in general, difficult to use successfully. So a very nice class called assert has one member, an int, and it's set to 1000. We compile it, and the main function creates an instance of that class, and then sort of on the command line, we want to see what the return value of main is. What do you guys think if we compile it with those parameters, what the return value is? Yeah? Exactly. But that's like ludicrous if you think about it. So what is happening here? There's an invariant to the class, and basically the meaning behind that is before every member call and after every member call, the body of the invariant is executed. And here it says A has to be unequal to 0, which is obviously true because we never set A to anything other than 1000. And also in the member function fun that we call, we in the in contract check if it's unequal 0. The out parameter, we check if it's unequal 0, and the body doesn't return anything. It's just saying assert false, which should definitely throw. And then also, we check that the return value from fun, which is at the definition here nothing, should be unequal from 0, and then we just return it. So what happened? A nice small parameter passed to the compiler, which is called release. Obviously, all of you know what's happening, but like the novice user coming to the language and looking for something new will not understand this. And the problem here is that release is basically removing all invariants, all asserts, and all contracts. So basically, those features in anything other than unit test block or for debugging purposes becomes null and void. We cannot use that. Or we remove the release flag, but then people say, oh, but then our benchmarks aren't as fast because we don't do bound check. Yeah?
I was just going to say.
The mic isn't.
Say that. Is the mic on?
No.
Hello? Oh. I was just going to say that assert false is left in even with.
Come again?
Assert false is still in there even with release mode.
But I don't see the error. I mean, I tried.
It should. What? Oh, yeah, it doesn't.
But this is the point, right? Like 3 very experienced D developers here were having different opinions on what is supposed to happen. Like how does the regular user coming from TypeScript going to feel about this? He's not going to take a second look. He's going to go to Go or to Rust or to any other language. This is too complicated. We can't do this. So my suggestion, don't use any asserts. Well, let me rephrase that. Don't use any asserts in anything other than unit test blocks. Invariant and contracts are pretty much, don't use them. It just doesn't make sense because you can't be sure how your code is compiled with what parameters. So, as I said, another thing, template constraints. I know all of you love them. I love them, but it's ludicrous. This is, well, taken from Phobos and stripped out, and I think index of is one of the nicer usages of template constraints. So we have an index of function, which basically returns you, as the name suggests, an index to a needle found in a haystack. And here it's specifically for strings. But because there are different prototypes for the function, so you can search for substrings or for characters, and you can not only search in a string, but also in a range, we have to basically do the overloading for the templates with constraints, and this is done here with the if statement. And the first 2 are quite simple. The first thing is we test if it's a range, and that the element type of the range is a character, and then we also test that the thing that is passed in is not a string. On the second one, we just test that the thing that is passed in, or that the character C here, or the thing C, is a character. And that works because then it matches strings, because strings are just like arrays of characters. But then there are more things. So we have like a case sensitivity parameter, we have the start index parameter, and we have to basically do like a constraint that is true for this one function that we actually want to implement, but is false for all the others. And it just scales terribly. And it even continues even more. There are more functions. And then after we have done the initial checking, we pass it on to the actual implementation, because those have to be different for ranges and for strings, because for ranges, you can't slice them if you have a start index, and so on and so forth. It just becomes, like this becomes difficult to understand. And obviously, with sort of growing scope of the project, you have to add new stuff, and it goes on and goes on. And then half a year later, you're looking at this and like, what is going on here? Like, I need to write out all those ifs or template constraints to make heads or tails out of it. And I've done that. I had like long pragmas just printing out one at the other, the Boolean values, and trying to understand what's going on here. And I think I know where this is coming from. So in the good old days, when C++ didn't have const expr, they had something like this. And the acronym, if I get it right, please correct me if I got it wrong, is substitution failure is not an error, SVINA. Attilia agrees, so I must be right. And in main here, we want to compute the Fibonacci number for the value 10, and then want to return this. So how this works is do I have a laser? Yeah, but you can't see it. So the template parameter is passed basically either as a name, as in the first template of Fibonacci, but also you have different declaration of the template where you instantiate that value. And here we have 2 instantiations, basically for the recursion anchor for 0 and 1. And then what happens in the first templates on lines 4 and 5, we take the value that is known at compile time and instantiate that for nested template instantiations of the same template. And eventually by subtracting 1, we're going to get to the place where we either match the 0 case or the 1 case. And I think this was, like, the position is so close to where template constraints with the if keyword goes. I think this is the root where this is coming from. Walter hopefully knows or hopefully has forgotten, but anyway, this is so close that I think it's right, and for the purposes here, as I'm on stage, this is the place where this is coming from. And this was already, when I first saw this as a young student, I was like, this is magic, but that is dark magic. That's, please not do this. So, how to make this less terrible? One obvious thing is bundle all the parameters in a struct and pass that in. And then what you do, only having one template implementation here, is check your different varieties of inputs inside of the body itself. So all we're interested here is to say, is the element type of the range a character? And if that's not the case, you're going to static assert and print a nice error message. And then inside what we do is we basically do a jump depending on the types that we get. And with static if, that becomes nice. You have like an implementation function for ranges, and you have an implementation function for strings, and you can test them separately, and you know how the code is flowing. And here, sort of the nice trick about that is, if you don't have any parameters, you just sort of take the init value of a struct and pass that in. And it's easy to understand. There's one place from where all the dispatching is happening, and it just works, and it's easy to understand. Another way to do this, which is a tiny bit more tricky, but might be also interesting for people, if you don't want to construct a parameter structure instance and pass that, is do something like this. So you always need our haystack and our needle, but also we might have additional arguments. And one thing that you could very easily do is you have a static for each over the members of the parameter struct, and then we have to do a tiny bit of template magic to unpack that, because the structure is containing, as seen here, nullables for the start index and a nullable for the case sensitivity. So we use the unpack template to get sort of the base type of the nullable, and then check if it's equal to the type of the argument that we are currently iterating. And if that is the case, we assign it to the index of parameter struct and move on. Obviously, this is one gigantic drawback, which is that you cannot have two parameters of the same type. But I would argue for most functions, that is something that you should desire in any case, because what will happen is if you have two parameters that have the same type, and lo and behold, they are just behind each other, so let's say index 1 and index 2 for the parameters, people will mix them up. And we're going to see an example of that later. So this might also be an option. And in this way, you can just add parameters to your index of parameter struct and just recompile and it will work. You can just pass stuff in. So template constraints, don't use them. It's not going to help you. It's just going to make your life miserable. Maybe not now, but in half a year's time, it's going to be hard to understand. So I said I'm going to try to make enemies here. I'm going to suggest to not use other things as well. One of those things is nested functions. Pardon my French, I think they're not good. And I wanted to say another word, but then just remembered that Michael has to bleep those words out for the YouTube upload. And last time he had to bleep something out. So they are not good. And Walter had a nice statement many years back where he said nested functions are a good replacement for gotos. And I'm like, that's like putting lipstick on a pig. Like, it's still a goto, but it's not called that. So let's not do this. One of the major problems with this is the internal toString function, that is, or the nested one, defined on line 4, you don't actually, if the function gets bigger, it's going to be very hard to figure out from where the parameters that it's using are coming from. So the appender here is declared at the beginning of the toString function. Like if this function were longer, it's probably very hard to know where it's at. And then also you have variable shadowing. So if you ever have like another appender that is local to this, it's going to be even more difficult. And also the internal toString function is dependent on an index that is well, set in the outside function, so to speak. And it's just not worth it. What you do is you pull it out, you make it private, you pass all the parameters in, you write a unit test for it, and then you forget it and it just works. This is just making your life more difficult. No nested functions. Yeah, what is also very bad, and I said I have something for everybody here, nested imports. It's just not helping you. So you're going to have a toString function. It's going to import stdconf at some point to use the to symbol to convert the actual value to a string. And then you have another one somewhere, and you're going to do the same for double, and you import the thing. And then you have many others. And also, what do you do if the nested or if the function is taking a parameter of type that is not defined in your in the model that you're currently working on? The nested imports will be split to some global imports and some nested imports. Have them all global. If you want to refactor, you take all the imports, you take the function, and then use the awesome script that Ruslan started to filter out unnested imports. And it's going to whittle that down, and quite quickly you have a small module with a few functions that only have the imports that you actually need. To do this is just making your life more difficult than it actually has to be. Yeah?
Yeah, but I want to point out that, for example, if you're a library writer and you write a lot of templates, it might be better for performance if you put your imports inside the templates than just to put all of the imports at the global scope.
Fair enough. I would say the same thing I say to Walter pretty much on every D Foundation meeting. The compiler is too slow. I think as a user, I shouldn't have to care. I should write the code that is easy for me to write in the first place, refactor, and then change over time and distribute. Like if why do I, as a user, have to care which imports are faster than others? Like, already, no, that wasn't me. So, as I said, so let's sort of get to the end. And I think this is where, like, why I ask you to all keep your stones and your tomatoes in your pockets for now. So, I think scope, ref, return, all those are good things. And I'm 100% sure that Dennis and Walter and others will eventually have something that is sound and correct and working and understandable and documented correctly. I'm 100% sure. Like, I might not be able to understand it, but if I were smarter, I bet I would be. But not in safe code. I think Andre once said when there was discussion about deleting the delete keyword, it's like you have to have a toilet, but you don't put it in your living room. Like, I don't need this in safe code. Safe code should be simple and safe. And I think by removing stuff, we can get to that place a lot easier than we can get to there by adding stuff to the language that makes it more complicated. And there's sort of an interesting thing I read yesterday. Rust had a gigantic survey with over 10,000 participants. And the biggest complaint that Rust users had was that Rust was too complicated. And I'm 100% sure that D without DIP 1000 is already a lot more complicated than Rust. So I don't want people to use Rust or Go. I want this crowd to be so big that I actually have to hurry to buy DConf ticket that I get a seat. And I think by making the language more complicated, we're not going to get there. So maybe a suggestion to not get stoned later on here. The DIP 1000 work, I think, should move to trusted. Trusted is, sort of, at least in my opinion, just sort of a bastard child between safe and system code. It does nothing else than being callable from safe and then calling system. But in it, well, the name is a bit wrong at that point. We don't really trust. We verify a bit as well. But I think those mechanisms should live there. And safe should be simple. And you shouldn't be able to take the address. You shouldn't be able to slice a static array. And you shouldn't be able to return via ref. So, and for all the other stuff, you ain't going to need it. Like if you want high-performance code, as Dennis already mentioned, turn it into an array and iterate over it from front to back, because that's what graphic cards are doing. This is what SimDcode is doing. And if you are too smart, the compiler will not be able to follow, or the optimizer will not be able to follow you. You ain't going to need it. Make it simple and understandable. And then sort of finally to say, simple is better than complicated. And I think we should think about what Scott said nearly 10 years ago, every time we propose a new feature or want to build a library or build a new API. Simple is better. Oh, and as Ethan hasn't shown me the time yet, I have one more thing to say. So small appendix. Please don't add tuples. My favorite examples why tuples are just the wrong idea. Assuming you have a GPS function that returns a tuple, longitude and latitude, and in main you assign that to latitude and longitude, and your airplane will do as it did yesterday over Great Britain. It's not going to make it here. So, thank you.
I want to congratulate you on some original thinking, things I've never thought of. And I'm really intrigued by your idea of altering the meaning of safe to be more of a subset. And what I encourage everyone here to do is to try it out. Try using his suggestions when writing safe code of avoiding pointers and stuff like that, and let's get some real-world experience with that. And I'm really interested to see how it turns out. How far can we go with this?
I mean, from my own personal experience, you get nice, boring code that is sort of doing the expected thing. Yeah. And like when you come back half a year later and you think, who wrote this? And then you look at git blame and, oh, it was me. Yeah, makes sense, nice and boring.
So yeah, I mean, I'm going to try it myself, your ideas, and see how far they go. And I encourage you all to do it too. And let's see if we can make this work.
Yeah. And the really cool thing about not taking the address, that's a user choice in most cases, and also returning by ref and slicing arrays. There's nothing that DMD has to do to help you. You can write this code right now. It's just sort of that you have to remember not to take the address. If there's anything you want to take away, don't take the address. It's never going to add good.
Yeah, we need D as a library to write a linter that says don't take the address.
So where's Jan and where's Rosman?
Yeah, you can. It's very easy.
Cool.
Yeah.
Okay, first of all, that was unbelievably based, though of course you are terminally wrong about nested functions.
Come again?
No, actually, I just want to confirm we've been writing like user phasing or domain code without pointers for years, and it works. You can absolutely do it. Like all the pointer use we have is deep in frameworks where you're using trusted anyway. So as an addendum about tuples, your problem is not that you have a tuple, your problem is that you have tuples without names on the fields. Like if latitude and longitude were names and that was actually checked by the type system, that error couldn't happen.
Yeah. Yeah, and I sort of skipped over the part where we already have a tuple type in D. And if you really want to shoot yourself in the foot in changing longitude and latitude, you can already do that. So I don't think we have to put that into language to do a mistake. We can already do the mistake.
I want to echo Walter in saying that some of the ideas are really good. In fact, before you showed the last slide saying we should put it in trusted, I went, maybe we should put that in trusted. So very interesting, but I also want to echo the previous sentiment. You were terminally wrong about a bunch of other stuff. And just to echo what I said many times last year, wait for my talk.
Your talk's on Thursday, right? Yeah.
Wait till Thursday again. Any more questions? Yes? Hey, I got a question for you, Dennis, while you got the microphone. How do you feel about that talk?
Yeah, I don't think with my own code I would be able to like use your idea of ref. You have like strings and static arrays with a size. They don't convert to static arrays of another size. So I'll have to try it out. But as for my question, so as you said, as a user, you just want to write nice looking code. And you showed an example of accessing an array with get and an out parameter. But what if the user says, I don't want that. I just want to use a nice looking index operator?
Yeah, but like, come again?
That's unfortunate.
Yeah, like, obviously you want nice code, but you also want correct code, and I hope, or I'm pretty sure that you want correct code over nice code.
Okay.
All right, do we have any more questions?
Come on, where are all the tomatoes?
One thing I noticed in your presentation, in your examples, was like nullable was pretty important. What would you think about like having special nullable type syntax?
I don't like it. Like, I've done quite a bit of TypeScript now, and it's pervasive. It sort of gets everywhere, even if you don't really want to. So I would say the nullable type, as it's right now, is ugly in a way that you don't want to use it, and that helps you to structure the code such that you don't go for that. Like, you try to make it not with nullable. So yeah, I would say like the bottom line, not to have that in the language. And that also comes back to the point that I wanted to make. Simple is better than difficult. Like, the language in itself is already too complicated. And if we have a nullable type that is inbuilt, it's just going to get more complicated. And as Timon so nicely showed, it's already, like, types are already so complicated that I have a lot better chance of understanding div 1000 than I have the actual type system.
I'm curious. I don't like that you're picking on nested functions. But I think that there were other candidates, and I'm curious, I mean, what do you think about things like in-out, template mixins, safe at the beginning of a file, or private, or stuff like that?
So yeah, the list I sort of showed is definitely not exhaustive. I mean, alias disk comes to mind. That's like the first thing needs to go, right? But there's only so much I can rant about in 45 minutes. Like, maybe wait for next year. Or for a lightning talk, I can give you a list of things not to do, just bullet points, and then I'm going to run out of time there as well.
Yeah, but still, picking on nested function is like picking...
Yeah, like, I don't know, I just have a hate for them. Like, what can I say?
So, Robert, did you just say I should sign you up for a lightning talk?
Do it.
I fear I did, yeah.
All right, I think we're done for questions. So thanks again, Robert.
Sure.
And especially thanks, you left everybody 20 minutes for a break. Woo, enjoy them. Yes, yes, we are back. We are back. Everybody downstairs, come on up. We are back. Hey, Walter's in the room this time. My metric is when Walter sits down, we start. So everybody downstairs, you got about 15 seconds. No, don't go quicker. Give them a chance, all right? Just one chance. All right. Ruthless, ruthless. All right, you snooze, you lose. Everybody else, let's keep going. Stephen, what are you going to talk to us about today?
It's going to be about converting C code to D.
Yeah.
Yeah.
So this sounds like it's going to be fun. Everybody ready?
All right. Before we...
There's no programmer energy. They're not ready. Also, there's no display. Should we fix that?
No, that's right. So before we start, I just want to show this informative video to everyone. We good? I wonder if you guys recognize the studio I filmed that in. All right. So welcome to the clinic. So this is about my adventures of porting a large, I think this works here, large C library to D. Yeah, okay. So why are we here? This is kind of the story of how I did all these things face planted so many times so that you don't have to. I'll start off, this is kind of like an overview of how this is going to go. I'll start off with how I became involved in this project and the various stages I went through. Brief history. You may have seen my blog post a few years ago. D is a teaching language. I teach a homeschool class on coding. We first started out, there was kids that didn't have laptops, so I was like, well, what can we use just to get them started? And some of them had tablets or whatever, so I was like, okay, we can try JavaScript. We'll just do JavaScript in the tablets. And it was the most obvious choice as it runs everywhere, but there's not much you can do with JavaScript on a tablet. You're just basically manipulating web pages. It's not that great. So we went to Roblox. Roblox is a kind of a neat development system where it's got physics engines and 3D graphics and everything. So we went with that. Has Lua as the base, so you guys remember talk from last year. It's a nice base, but it's not really a lot of opportunity for regular learning. Like you're just basically hooking pieces of Roblox to a little bit of custom code. And since it was something I'd never used before, I spent a lot of time dealing with the quirks of Roblox that I wasn't aware of. And of course, after that, we had to go to D. Kids without laptops now could borrow some. for the class. I started small with some like text-based games like Hangman, but obviously the plan was to move to graphical games because that's what kids are interested in, right? And so I found this library as I was asking, like, yo, what's a good like video games programming system in D? And somebody pointed me at this YouTube channel with I'm not sure if I pronounced this right, but Kyril on YouTube, and it's a C library, but it has D bindings. And this is, if you want to visit this website, it's a really great introduction to doing video games programming with D. And I could get this up and running, like basically, aside from installing the compiler and MSVC and all the other things, we got it up and running in like one lesson. We could just actually make rudimentary drawings on the screen. So that was pretty good. Watch this, make sure I don't do an ollie here. By using Raylib, I could focus on the overall design of the game development, like how things work, and not get held back by the complex systems. Like if we use Unity, it would be all involving a whole bunch. It was kind of like Roblox was like that. It's like we have to deal with all the intricacies of Roblox and not just worry about the code, whereas Raylib is super simple. So there was the Raylib debinding. And this was included as part of the video series with Kyril. And it was provided by a GitHub user. And then he deleted his account. Like deleted the entire GitHub account. So I still needed it. But it's open source, so I resurrected it. And now I am the maintainer of RayLibD. And going on four revisions so far. And it's not that bad. Like with help from other users, I have a whole plan of how to build the next version. I could do it within a matter of minutes, maybe like a half hour, an hour. You just have these instructions, and these are the tools I use to do it. But first of all, this is just a bunch of examples of stuff from the class. Everything up here was pretty much either built in class together or by me, except for one. There's one that a student made. All right, so the first stage in our journey here is how do we do bindings? How do we bind from a D program to C code? D follows the C ABI of the platform of the system, which is really nice. You don't have to do any translation layers or FFI or any of that stuff. It requires that C code is built using the C compiler for the moment. A great tool that we use, and I've used it in, this is how I make the Raylib debinding, is DStep, made by Jacob Karlberg, who I don't think is here this year. And it generates bindings automatically from C headers. This is kind of an example. If you have the following C code on the left here, which has some types and some pound defines and a function prototype, you get that on the right. All pretty straightforward, this is not like complicated stuff. But it's not perfect. It's a little bit messy. We have, of course, the C preprocessor. As you know, the C preprocessor can build whatever you want. And sometimes macros are part of the API. As Walter would say, it's non-hygienic. And there are some ways to replace macros with mixins or inline CTFE functions, but not everything is doable. However, most of the time for bindings, you just figure out the little bits that are different, and you fix those. So the instructions for creating RayLibD are in the generating.md file on my repository. We start with DStep with a specific command line to say, skip some of these things. Then there's a bunch of cleanup steps afterwards. And then we can test against known projects, right? So the most important thing about this is automation. We have to have automation because I don't have time every time Raylib comes out with a new version to go through and diff everything and make incremental changes or whatever. I just want to take what's there, go through my process, maybe it's not all automated, but it's automated to the point where I don't have to do much, you know, and I can go through the process without thinking. An example we had was, and Raylib is kind of explicitly stated he doesn't care about being backwards compatible. Like there was one function that was a rotate vector function, which changed the float argument from float degrees to float radians. Which was awful. Like, oh, I've created the new binding. Let me run it against my thing, and it was like a ball bouncing game, and the ball's like going. It's like, what just happened? Oh yeah. So, yeah, these are some of the reasons why we do this. Don't have time. C has no name mangling, so if you get something wrong, like parameters change, whatever. That thing we couldn't detect, but if like the number of parameters change or the types change, C doesn't help you. You know, if you link against the wrong thing, and it's just going to crash. So struct differences cannot be detected. I think this is the same thing for D, anyways. Like D doesn't mangle the struct contents as part of the function, but you know, automation is just required because you're not going to deal with all these little nuances. Using continuous integration, which I would like to do in RayLibD, is a great way to fix this because you just basically, once you've changed, your continuous integration builds and tests everything. You have some nice tests in there. So we've gotten that far. Now, this isn't something that specifically I did. It was in the binding originally, but we don't want to use D to write C, right? C libraries are written in C, as we all know, but the D binding doesn't have to be, right? So let's compare these two things. This is an actual function or a line from my pinball game that I was making. And if you look at the C way, is there a laser thingy on here? Yeah, I can't see it. Anyways, but this is the actual line in my code at the bottom, right? Using operator overloads, looks pretty nice, right? This is how you would have to do it with the raylib functions. Because C has no operator overloads. I much prefer that. And it's actually pretty easy. There's a mix-in you just include in the structs, and it says, oh, I'm going to be able to multiply things together or add things together, and it's actually pretty easy to do. So we can add to that because, you know, even though we're binding to the C code, we can add functions to classes. We can add our own functions, whatever. We can add extra pieces on top of it that make things nicer. This is something I haven't done yet, but I'd like to. Enumerations in D are type. In C, they're always a constant. So it's just you have an enum. You can even name the enum. It doesn't matter. Those are still global in the global namespace. So this is an example of an enum value from raylib. Notice the highlighted extra repetitive words there. But I would like to do like just keyboard dot comma, right? That's much better. And we can do this with D because we have introspection. So most of this is, but you don't have to write it all the time. You just have this one little thing tucked away somewhere, and then this is all you gotta do. Just mix in, make me a better enum, and there it is. So we can use introspection to make some cool things like that. Wrapping C abstractions. I don't have my presenter notes because I couldn't figure out how to get that, so let's see what's coming up next. Oh yeah, adding UF CSM methods, I talked about that. Overloading, yes, overloading works. Strings. So C strings kind of suck. They're a pointer with a zero termination at the end, and D doesn't use that, and it makes it really hard to communicate back and forth without doing loads of extra allocations. We'll talk about that later. So, got to the point where I had this raylibd library, and it's okay, but using C from D is still not great. There's so much cruft in C. C strings are horrendous to use in D. D has fantastic string manipulation, but then using with raylib is a pain because you have to convert to C strings. And then this is a list of all the ways you can draw a rectangle in C. With all the different functions, you have to match the name with the types. And I think we could just do that all in one overload. Just to talk about the string problem here, raylib has this function called text format. So text format is essentially sprintf. Does everyone know what sprintf is, right? What he's done, which is really nice actually, is because this library is targeted for kind of beginners, the thing you don't want to throw on top of beginners is manual memory management. That's like, a difficult thing for beginners to deal with. So sprintf requires that you pass in a buffer. Well, you got to allocate that buffer somewhere in the stack, whatever. Text format doesn't require a buffer because it stores a buffer as a static member of it, variable inside the function, and just sprintfs to that, and then returns that memory. Simple, it works, and then you don't have to think, like most of the time you're just saying draw text format, score is X%D, you know how that works. But with D, if I want to use my D tools to make strings, I'm going to get a string that's not zero terminated. So now on top of that, to my kids, I was having to explain, well, you can use the D functions, but now you have to call this function called toStringZ. Don't ask me why you have to call it, you just do. Because these are kids who don't understand. I'm trying to avoid talking about pointers and all the other stuff that they have to deal with. But D is great for that because it has the GC, a lot of memory management is already taken care of. But, this kind of stinks. Now, wrapping is a possibility, but it has some drawbacks, namely allocation for no reason. And so we kind of need to use C as a dependency is another problem. Even though in dub, you add dub, add raylibd, it comes in as a dependency, fine. But you still have to somehow inject the pre-built raylib library as a link step. So it was kind of, every time someone wanted to start a new project, I have to remind them, okay, you got to go in the JSON file and add these lib commands just to get, and then also download the raylib library. And after a while, I decided, you know what? No, I'm going to put the pre-built raylib libraries into the repository, and I made an installation tool that now copies that library to your local directory. And it's there. It's still, you still have to edit your dub file, which maybe I could automate that, but still, it's just, it irks me. So even with using all those tools, I can't anticipate all the issues, like, maybe somebody has a weird built raylib library. I don't know how that's going to work. Raylib actually has a lot of, and this is the thing that C libraries do, a lot of configuration options you can specify, like, oh, I want to include JPEGs. I don't want to include JPEGs. I want these other file formats, which are build time decisions that I don't know what's going to happen there. But the holy grail here, the thing we want is for dub, add raylib, and then you build your application. I don't want to have to download anything else. I just want this to work. So I created a new library called draylib. This is a really hard name to figure out. But anyways, the goal is to port all the C code to D. Kind of an ambitious goal. But I thought, you know what? I've always preached that, you could practically compile C code as D. I'm going to practice what I preach. No more need for the C compiler or custom pre-built libraries. Great. I just add raylib and I'm done. Or draylib. two developers. I just have to give props to Real Dwa, who is a member of our Discord and a frequent participant in DConf, who's helping me do this. And once fully ported, like right now we're just porting it, the API will be deified, meaning that I'm going to take out all the C crap and put D in there in its place. But we want the simplicity of Raylib. So I really like Raylib, the C library, because it's very easy to read and understand. The API is pretty simple. It just is missing some things like operator overloads, overloading, those kinds of things that just make the code read nicer. So yeah, how hard could that possibly be? Copy, so this is the first thing I did. Just take the C code, copy to a D file, and build it. What happens? Well, the first module I did was the core library, which contains all like the static state, does the event loop and all the things. As I went, I just basically would comment out a piece of code in rcore.d and copy the code into rcore.c, copy it into the D file, and then compile, fix it, and then test against all the examples that are, Raylib has a ton of examples, so I just start testing against the examples. Oh, it still works. And you can see from the screenshot, basically, I added this little D port thing so I can know, oh, it's actually using the D code. Then after that's done, do it again. Copy some more code. Test again. Fix the errors. The annoying little things. These are the parts that, and I have it listed at the bottom here. Watch Dennis's online talk. Dennis is going to come up a lot in this presentation. Watch the online talk that he made last year about his porting tool. Basically, simple things like null to null, arrow to dot, moving array indexes around, et cetera, et cetera. Those things just are tedious and annoying. But I did do them. At this time, I did do them. I was just like, okay, I'll just search and replace. Some of these things I search and replace. Some of them I have to like think about, and you know, the array, you know, order, how you declare arrays was not as easy to do that kind of stuff with, but wasn't too bad. We're still building using C code, so for the things that we aren't working on yet, that aren't rcore.d, just use dstep to make bindings for that. So we're still linking like C code with D code. It's like a Frankenstein, ridiculous thing that we're making. Some small modules you can just port quickly, like, you know, a couple hundred lines, so I did that too. A large, complex dependency in Raylib is GLFW. Who knows what GLFW is? Yeah, a lot of people. So it's actually completely included inside Raylib. So Raylib has an external directory. Like, this is one of the goals, right? He wants to be able to completely build without any kind of downloads or whatever. I want to control everything. Mostly all header-only libraries, and then this GLFW. For now, we're just going to use the bind BC binding and keep building with D. I'm glad that bind BC works. In fact, I don't even use like a download. I use the library built inside Raylib and just use the binding from bind BC. And then I noticed there's a GLFWD project, which is actually a port of all the C code of GLFW to D. How did that happen? We'll get back to that. Okay, finally, rcore.d fully ported. In my side time, like at beer confs and other things, several functions at a time, it took me from June to October, about 7,500 lines of code. My estimate about 40 to 80 hours, so like 125 lines of code an hour. Okay, that's not too bad, but it was working. Everything else is still C, remember, it's just rcore. How much is left? So Raylib itself still has more modules to do. We got our textures, 4,800 lines of code. Our text, 2,100 lines of code. Our models, 5,900 lines of code. And more. And then there's the external libraries I talked about, you know, GLFW. STB image, 8,000 lines of code. STB Vorbis, 5,500 lines of code. And no, this is not a typo. 70,000 lines of code in mini audio. Apparently audio is really complex. And there's more, right? That's not all of it. There's still more stuff in there. So it became very clear that manual porting is not going to cut it. So we did a side quest here. Maybe we'll leave stuff compiled. Maybe it doesn't all have to be D, right? There's no public API to these. Like there's no exposure of GLFW or STB image to the Raylib API. They're just internal details. They're implementation details. So maybe we can just keep compiling that with C code. That just has bindings, right? Maybe import C will work, right? I mean, this is something I tried recently. The latest DMD and LDC has a built-in C compiler. Maybe we'll just compile those implementation details with import C, and we still won't need an external C compiler or have to worry about various odd discrepancies. But it doesn't work. I really do like the idea of import C, and I think if it can happen, if it can get to the point where we just say, I'm going to import this header file and it works, and everything is handled, it will be game-changing. I absolutely would use it for these things. But for right now, I'm not going to dig into whatever this is and try and fix my macOS library headers.
Oh, Stephen?
Yes?
I need you to get those errors into Bugzilla.
I did.
Did? Okay, great.
In fact, we were talking at BeerConf, and you said, put them in Bugzilla, or try it, and if you find anything, put them in Bugzilla, and I did.
Because, you know, this is the whole point of import C is to solve this problem you're having.
I think that is the goal, and I think that it's doable. But for now, I can't do it. I'm still not working. So I'm resigned to the reality that I'm going to have to use pre-built C object files. Or maybe invoke the C compiler from Dub. But Dub does a very poor job managing external artifacts, I think, still, right? There's no movement there yet. There must be something better. How did that GLFD port happen? So now a miracle happens. I messaged Dennis and said, how did that happen? Did you just slog through it like I'm slogging through it? Or did you do something else? And of course, yes, I have a tool that I haven't published yet. But here it is. And that was a miracle. It was, thank you, Dennis. Like, just amazing. So now we're moving on to stage 4. Now that I realize I can do this, I need some more tools. Or I need to deal with C2D, make that tool work. So C2D is the tool that we're talking about. Again, watch Dennis's talk last year. Based on tree sitter, so it allows you to deal with not quite parsable code. Thank you, C preprocessor. Handles a lot of the minutia, like the null to null, the pointer, all that stuff. Maybe it's a solution to purporting these implementation details. Great, I could try it out. I did. Now, the first thing I did was my next project in the thing was rtextures.c. That requires stbimage.h and stbimagewrite.h. There's like a few files that are in there. C2D gets much of the way there, and during this process, I filed almost 30 issues and bugs against C2D, and Dennis fixed them usually in like 2 days, which was awesome. And now I have to run the process again. So imagine this, you run C2D, you start building it with the decompiler, and it's like, oh, fix this line, fix this line, fix this line. Okay, you go through like 30 lines. And then you get to a point where it's like, wait a minute, C to D did this wrong. Now I gotta get that bug fixed, and now I gotta start over. Right, I gotta go back to the C code, run the new tool on it, fix those 30 things again, and then get to the next spot. So the most important part of porting C code to D, you can guess, automation. We want to automate as much as possible, right? Just like the bindings, we want to automate as much as possible. Without automation, you'll never get there, right? You guys all remember Daniel Murphy's project to port the decompiler from C++ to D. Without automation, never would have happened. Also, C to D is not enough. Thank you, C preprocessor. So you can see something like this is inside Raylib. This linkage thing is not it's not real code. What it is on Windows, if the isDynamic definition is defined, then we're going to define linkages, declspec, whatever that is, the MSVC thing for exporting DLL symbols. Otherwise, I forgot to include it in here. There should be an else, define it as nothing. And so it either gets replaced with a blank or that. This is what C to D does. I still have the linkage variable. And in fact, I think in a previous version of it, it would treat that as the type. So it would say linkage foo. And yeah, that didn't work well. And you also have this stuff at the top that isn't even useful. That's okay. That's the kind of stuff, it's like we can automate a lot of it and then just fix it up later. But I still need something to be more cognizant of the C preprocessor. So I thought, well, maybe I could just solve the macro problem by expanding the macros, right? Once this file is ported, I don't need to touch it again. It's an implementation detail, right? We don't care about versioning or code aesthetics. It could be as ugly as sin, and I'm not going to look at it again. So I wanted to focus getting it working on one platform. So we'll just run the preprocessor that replaces macros. But the problem is that if you run the preprocessor on a file and it has imports, what's going to happen? It's going to pull all the files from all the places, paste it all together, and now you're left with this giant thing that is not usable as a C to D thing. Now, Adam Rupe, is it Rupe? I don't know how you pronounce it, but Adam, everyone knows who Adam is, had this mention that GCC has the D switch for debugging. -D, capital D, capital I, keeps it does the macro expansion, but it keeps the existing macro definitions and includes. So C to D can still see them and substitute those for imports, and it also includes, and it also keeps the include statements. And then it also expands to macros, which is what I want. The -C switch keeps comments. I didn't realize this, but the C preprocessor strips all comments by default. We can't use that, right? We need all the comments in there. Excuse me. And it also outputs a whole bunch of garbage. #1, you'll see what it looks like. But using that output, if I write a tool, I can get the macro expansion we need and get back to the original code by removing the included files. But what about other compilers? Like, that's good for GCC, but what about Clang and MSVC? Clang does not have the -D option. MSVC does not. But they both have an option to keep the comments. And with comments, I can work with this. So introducing a new tool that is basically the goal here is to just expand the macros. That's all I want to do. Step 1, detect all the pound directives and instrument them with these things. Why do we have 2? We have 2 because if that pound is like a pound else, then everything above that is going to be stripped out, or everything below it's going to be stripped out. So I need one of them to survive, so I can recreate what was there. The number is to make sure that if I see both of them, then I can not output both of them. Because remember, when the C preprocessor runs, that pound-defined foo bar is going to be gone. All that be left with the comments. So let me show you how it works. Inside foo.h, I didn't actually include in this slide, is a pound define of bar for 6. Now, Walter will have nightmares watching something like this because this is what the C preprocessor should never be used to do, but it is used to do these kinds of things. Instead of defining functions normally, we're going to use a begin and an end. Can everyone see that? Am I like in the way? And then we just put our code inside. Great. So what we're really looking to do is turn this, like CTD would never be able to handle this. But we were looking to turn this into the expanded thing that the preprocessor would do. First thing I do, put in some boilerplate stuff. Every pound you see just puts the thing in a comment, and then that's it.
Steven.
Yes.
The word for begin and end is no hire.
Exactly. So this is where we were. Oh, I didn't update this slide. But imagine that looks like this. But this is what it should be. It should still say the begin and end stuff here. But anyways, we run it through the preprocessor, and this is what comes out. This is all the garbage I was talking about. So each of these things are like directives to the compiler itself to tell it things about like where I am. If you have an error, it's going to tell you you had this error in this header file. It's not really in the temporary file you've made here. Because we have the comment switch, we're keeping all the comments, which is essential because that's how I'm going to recover this. You see where it included foo here, but there's nothing there. And the reason why it's nothing there is because all foo had was a pound define in it. That's already gone. The pound define was bar is 6. So remember over here we said in x equals bar. Now it says in x equals 6. And if you imagine this begin, main, end, now turns into that. This is real C code. I can use this. Finally, the second step is I take this garbage and run my tool in recover mode, which reads all those comments and turns it back into this. So this is still C code, but my CPP tool has basically got back to where I was, but with the macros expanded. That's all it does. Finally, we can run C to D on it. I can cut out that junk, the begin and end junk, which obviously doesn't mean anything. And I get my main file, so I'm good, right? So now...
Can you go back a bit on the previous slide?
What?
Can you go back a bit on the previous slide, please?
Yes.
So isn't fn supposed to be appended over there at enum string begin?
It's supposed to, I don't know what you mean. On this, in this thing here?
Yeah, yeah.
This is just what C to D interpreted that garbage as. It's not real code. Like this is the best it could do. Like when C to D.
Yeah, to answer that, I fixed that bug recently, and now it will add extra quotes to put contents of fn in that macro. But it's still garbage.
It did. So. This is actually the latest thing that you.
Oh, then it might be a bug report.
Yeah, that's okay. But I don't really care what happens here because I'm going to delete that. That was just, well, I still leave all the pound defines in there because I don't know which things are going to be important for, C to D, and I can just delete the things I don't want. So that thing I'm going to delete because it's useless. Anyways. So now we get to find out all the problems. pound defines for things we expect. As you probably know, null is pound defined for 0. Seek end is pound defined for 2 or something. All these different things. So I got to put in a switch to keep those. There's also pound defines for things we didn't expect. Like, did you all know that sprintf is actually a pound define? I didn't know that. Then we add a way to skip those pound defines I don't want to replace. Basically, in the pre-processing, just prepend some stuff that I'm going to delete later. No problem. Then we fix the process and do it again. As always, automation is important. There are things that can't be automated. I'm going to kind of breeze through some of these last ones because I only got 5 minutes left. Implicit integer conversion. This is where import C would be great because I wouldn't have to deal with that at all. 0 as null. So even though null is pound defined as 0, and I said don't replace that, I'm going to leave that there. There is still code in like STB image that says pointer equals 0. I can't fix that. Initialization with C, you can initialize an entire struct with that. We have to change that to an init statement, like equals the type.init. Comma expressions. I'll show you that in a minute here. And yeah, D also has some annoying things, like size of int times layers is, you know, D is like, wait, that might be a 64-bit number. It's not. So I just have to tell it, no, that's actually, you know, an int size of int. Those kinds of things you just have to fix up. This one, this is the comma expression. This is a line in the C code that when you expand the macro, becomes this. What the hell is this? This is a big nest of comma expression and what do you call those? The conditional expressions? The ternary expressions, yes. And what I got out of the way I figured out how to fix this is take the comma expressions and each individual comma expression make it a lambda, where each thing becomes a statement. Yeah, it's bad, but again, I never have to touch this again. Once it's done, I never have to touch it. The reason C does this, by the way, is so that you can have this nice looking thing and it can put statements into an expression. That's all those comma expressions are for. All right. Thread local. This was a weird thing I had to deal with. Because this is static, so it's like private to the file, I could do this because the name doesn't matter. But because gshared is at the top of the file, I had to un-gshare the data. So I made a static inside of a structure and then alias that. That works. Variable shading, mostly easy to fix, just like most of its time, like iteration variables or something. Yeah, unreachable statements. Can we just get rid of unreachable statements as an error, please? Like, the reason this is like this is because you could define stbicert to be nothing, and then it has like a fallback mechanism to do something afterwards. But of course, D complains about it, so I got to comment that out. But there's just so many places where this is like, if it's an unreachable statement, just don't generate code. It's fine. All right, I'm going to skip through this kind of. There's a lot of things that, yeah, there's a lot of things that are just difficult to deal with because there's just no analog in D for this kind of stuff. Whether you're getting a defined through a makefile or from another file. Some other things that are not too important. It's kind of ugly, but who cares because it's implementation details. Let's see. Oh yeah, if you did, so this is on one platform. If I had to do multiple platforms, I'd probably just run the tool on multiple platforms and then do diffs maybe. But yeah, import C would be great. And finally, it happened. I finished porting this, and it worked. And it was quite a nice day when I was done with that. And if you subtract all the time of fixing C to D and building that other tool, probably I'd say like the final run through took me like 2 to 3 hours to port all those files, which is great. Like compare that to 80 hours or by hand. And then finally, the last thing for the future, I'm going to keep the C ABI. But yeah, first to go, C strings. We don't want those anymore. Better C right now is a requirement so that I can test against all the examples. Get rid of that. Maybe some memory safety in there. I did find a memory corruption problem when I first started doing this and had Raylib fix it. You know, like I said, change the way the API works. Constructors, we don't have constructors in C. It'd be much easier to do some of this stuff. And then also I kind of froze on Raylib 4.0.0. It's now 4.5.0. It was 4.2.0 as well. But basically some of the differences there. And maybe put a porting guide for people who use raylibd. And that's it. I just did want to say something about this picture. So I took this picture earlier this month. I went to a corn maze in Vermont. If anyone doesn't want to hear the secrets of this corn maze, plug your ears. But inside the corn maze, they had all these letters that you could go by, and if you saw the letter again, you're going in a circle. And there was clues too. So this is the big clue, and I just want to zoom in on this because I think it's pretty apt. Once you pass the C, do not come back past it again. Thank you.
Did you consider libclang and/or DPP?
I'm sorry, I didn't.
Did you consider libclang and/or DPP?
I didn't consider doing that. No.
Because libclang has this thing where it keeps all the macros, so you don't have to do any of those tricks. And DPP doesn't translate function bodies because it's not meant to do it. And
yeah, my first thing that I tried to do was use actually DMCPP. Is that what it's called? The C preprocessor that you have, Walter, Digital Mara. But I tried to just strip, just do the macros, but it was difficult to deal with.
Well, DPP does a lot of the stuff with the macros there.
Well, maybe use DPP instead.
Well, it doesn't do the bodies, though. That's the problem.
The trouble with DMPP, which is a C preprocessor, is it does a perfect job of implementing the C preprocessor specification. The problem is that most C compilers come with 400 to 500 predefined macros, most of which are unused and undocumented, and they appear and disappear based on what flags you pass to the C compiler, so it becomes basically an impossible job.
So just to mention that DMPP actually worked on STB image. Like it worked. But all I was trying to do is try and get it's those little macros inside a file where it's like, I'm going to define this macro here and use it here, and that's it. Yeah. In 2 places. Those are the ones I want to expand. I don't want to expand the pound includes. I don't want to expand, null to 0. I just want to get those hairy bits done.
I really hate to say it, but I think you did far more work than is necessary with this.
Probably.
And the reason I say this is all those problems you listed are problems solved by import C. Now, yes, you did have a problem with import C. It spit out a bunch of error messages. Well, import C has gotten to the point where when you see those messages, it's because the header file is using some wacky C extension. And once you go look at the header file or the line where it is, it's some wacky C extension, which you probably do not even need in your code, and you can just comment it out. But other things like dealing with the null, the arrays, all that stuff, the integer conversion, it's all handled by import C, and you only have to fix it once. You can just fix the header file to comment out the junk that you don't need and won't compile.
That's the full automation answer, which I would love to have.
Yeah.
But then I have to stop working on this project.
Oh, yeah, okay.
Well, I wait for import C to come about.
Yeah, well, import C isn't perfect. Okay,
Yeah,
but
it's coming.
I think it'll get you a lot closer than going back to manual conversion like this.
Yeah.
It's too much work.
Amory.
Yeah, so I have a remark and a question. The remark is that I'm super disappointed it's called Drelib instead of Relid.
You're super disappointed in Raylib?
No, that it's called Drelib instead of Relid, which was a much cooler name, I think. But no, more seriously, did you look at all the macro that the compiler includes automatically, you know, when it's pre-processing? It does so, I think, to keep track of debug information. So have you tried to emit the same one because when you are adding comment, you're going to change, you know, lines and...
Yeah, but all I'm trying to do is port the code. So once it's ported, I want the line numbers from the new file, right? I don't want the line numbers from the header files.
Okay, yeah, fair enough.
Yeah. Yep.
Yeah, Steve, thanks for the talk. I had a junior experience. I wanted to connect your comments with Walter's. I had a junior experience of yours. I didn't do something quite as ambitious. I was trying to get CUDA.h to give me automated bindings, right? And I ran into these same kind of errors, and I said, oh, crap. You know, this is just, okay, here we go. And I spent 2.5 days doing the manual thing, trying to automate like you did. I had a much smaller task. But then I discovered it was actually due to exactly what Walter was saying. There's all this, I mean, you can't, well, maybe Walter can believe it, but you can't believe the amount of external state crap that happens with a CPU processor. I mean, my gosh, it's ridiculous. And well, it's there. Anyway, the short story is I actually got back out, was able to get import C to swallow the whole thing and spit out stuff. There's one small addition that I had to deal with, but it's minor. And I wanted to say that before this experience, I had actually said this is a sinkhole, it's never going to converge, import C is a pipe dream, et cetera, et cetera. And now I think instead that there will be ongoing, like, forever problems. I think that there will be forever things that don't actually converge. But it doesn't have to be that. It just has to be much, much better than the alternative, which I think you're revealing your pain. I think thanks for sharing that. But
yeah, this is the alternative.
Yes, I just wanted to say that I'm a lot more optimistic than I used to be about it. So I'm glad you presented this, and I'm also glad that Walter tied it in. It mirrored my experience exactly.
Yeah. Also, to be fair to Walter, when I started this project, like I said back in like May or whatever of last year, import C wasn't even close to doing like preprocessor and stuff like that. So.
I see all the work you put in, and you know, I almost feel physical pain.
Well, some of it is like I just wanted to figure out what is the experience of doing this kind of a thing. Can it be done? Is it possible to do? And I think it's actually still valuable because I've learned the pieces that need to be handled to get there. And I think import C could use that experience as well. Yeah.
Question?
Yeah, two things. First, can we please stop making unreachable code an error? I think it's already not an error, it's actually a warning, but standard, the compiler treats warnings as an error.
Yep.
So you can just add -W.
Yes, it is just a warning, but in practice it becomes an error because dub turns warnings into errors by default.
By default, but you can switch it off.
What?
You can switch it off.
You can switch it off, yeah.
Okay. And the other thing is, as I understand it, import C, if you would use import C, you'd still have C strings, right? And you wanted the D strings.
I'm not going to use import C to, so
only for the internal.
Only for the internals, right? The raylib stuff, I'm not actually running my macro tool on. It's just C to D on that, because I want that to be as intact as possible. I just want the internals to be, you know.
Understood.
Well,
And in fact, when if import C gets to the point where I can run it, I think I could just swap it out. You know. Sorry.
Yeah, we're done. That's all the time we got for questions. So,
all right.
Thank you. And now we'll have a quick 5-minute break before the final talk of the day.
Said you needed to change the dev.json to add the lib.
All right, everybody, back upstairs. Actually, you are basically all upstairs, aren't you? This looks pretty full. Walter, what, man? You were here and now you're leaving us? Hi. Well, look, we're going to start without you if that's the case, all right? Bill. So we got our last talk of the day here.
All right, thank you. Vijay.
It's we've all seen Vijay before. We know who he is. Yeah? Look at them. They're all dead. They've had it. And yeah, OpenAI and service integration. Let's hear about it.
All right, thank you. Well, on the great side, it's only a 30-minute talk, and it's the last one of the day, so that's nice to look forward to.
We love you already.
So this big talk, what's it all about? It's basically how do you make D fit in an ecosystem where there's lots of people going on. Maybe you're in a company, there's lots of competing different programming languages. You want everything to play nice. Maybe there's legacy code. So how can you use existing tools to make your life easier? That's kind of the gist of it. So it's broken up in a few sections, which I'm going to get into. And also, who am I and why should you even care? So my background and my perspective, recently I've been spending a lot of time in Java, but it's mostly solving business problems under time pressure, and that influences my perspective and how I approach things. Lately, I've been trying to form my own business with D kind of as the heart of it, which is a great way of putting yourself in a position of these are some practical problems you need to solve very quickly. It's turning D into a practical language you can use. So I had this system I was working on. How did I get into this thing? I was building a service called Funnel, which is like a very high-performance data store. You can think of things like taxi services, micromobility, need lots of data to put into the system and query for it, and D is a great language for this stuff. So you got a good product, you're out there. How are people going to pay for it? Well, I don't want to write a credit card processor from scratch all over the place. That would be not exactly the best use of time. So how does everyone else do it? Oh, well, they use services out there like Stripe, for example. Okay, well, how do you interact with Stripe? Well, Stripe's got like this nice big old API out there, but it's enormous. It's really, really big, and converting it and building my own client would take an inordinate amount of time. So how do other languages solve this problem? Well, they got these nice clients on GitHub and other places. Well, how do they write them? They generated them. They didn't write them. Automation is the key to what they do. So does D have a tool to generate this kind of stuff? No, but it could. And this is where we're going to get into some of the standards that are out there and how you can make them be your friend instead of your enemy. So the context of this problem is companies often have very useful services, and they often depend on services in the outside world. Maybe you need to accept credit card payment with Stripe. Maybe you're using large language models to do sentiment analysis on customer reviews. Or maybe you're just writing a bot to integrate in Slack and tell you when your builds are done, that kind of stuff. But writing these clients by hand can be very time-consuming and error-prone. And you got better things to work on. You don't want to spend your time maintaining these clients and keeping up with every single change in the API. Not only that, but inside your company, there's other problems to deal with. Not everyone's using the same technology pieces. And you got to have an interface that is secure, it's simple and easy to understand, and it may potentially need to support multiple programming languages. Companies have all sorts of reasons for using different programming languages. One could be because the initial founder liked a programming language, and that's being used. Or maybe the local talent pool. You can only hire programmers in this area that are using Python or TypeScript, and then later on you switch. Or maybe you run into specialist problems that need languages to solve them, like most of your systems in Node.js. But then you're also running a piece of your system that's like a real-time auction or like a credit card authorization system that needs to run very quickly, and then you use a specialized language like D or Rust or Go or something for that performance-critical part. So you often end up with this heterogeneous environment. So in order to get these things to talk to each other in a fairly standard way, you need a protocol that they all understand. And a common way of doing this is this notion called REST, which stands for Representational State Transfer. And it's like an architectural style, but it's loosely defined exactly what it means. Like you're describing like nouns, like things by URL and actions you can do on them, which are like HTTP methods like post and get. But the exact protocol of what data you're transferring, whether it's JSON or Apache, Avro, or protobuf, it's not exactly determined, and you can't precisely document what it is in a consistent way that everyone understands. It's a little bit on the vague side. So what's OpenAPI? You likely have heard of it in its earlier forms because it used to be called Swagger and was developed previously until it was adopted by the Linux Foundation in 2016. At this point, it became a widespread standard that's not just in its original language it was built for, but it can be used for other things. It's often used to describe API interfaces in a programmatic way, and because it's standardized, that means there's tools you can get for free. It's built on top of an older standard called JSON schemas, which are ways of like describing how do you actually have validation of JSON data, which by its nature is not really well formatted, not precisely defined. It doesn't have the equivalent of an XML schema. So the JSON schema was an attempt to standardize this, and the Swagger API, the Open API system, builds on top of that. So there's a lot of services that do it. You can go to websites like apis.guru, and there's about 2,500 and counting services that are using it. Whether you need something for banking or you need any other service that's out there checking weather information, chances are very high they're going to be using an Open API specification. So if you want to interact with the outside world, that's the place to go. And because it's a standardized format described in a specification, you can use tools no matter what language they're written in. So if I want a tool to visualize my API for my QA team to actually use, maybe they don't use D, maybe they use another tool that's out there. You can take advantage of documentation generating tools used by someone else in your organization, and you get to the endpoint, the goal you want, without any effort at all. So this is an example of a tool for Swagger for taking the Open API specification of a tool and turning it into like a web page that's clickable. You can expand it. You can get descriptions of all the parameters that are out there. So if you want people in your system to quickly learn how to use your system, you can get nice, pretty graphical interface for your documentation very quickly, presuming you described your interface using the Open API. So what is this specification? Like, what is it? It's a JSON document at its heart, or you can write it in YAML. They're convertible to each other. And at the top level, some of the most important pieces of data inside of it is this the description of the servers. So when you publish a service that's out there, you're actually including things like what is the URL, what is the domain of the service out there in the world that's actually providing this. You're also saying how is it secured? Is it with basic HTTP authentication and password, or is it using OAuth 2, something else? And then you describe your endpoints as paths, and as you describe your endpoints as paths, there's often a lot of reusable pieces of data. Maybe I have the same error structure that's used by like 50 different endpoints. All that common logic goes in this section called components, and here you can define things and then refer to them later on when you're defining your paths. So here's an example of what the actual contents of a piece of an Open API specification looks like. I believe this one is drawn from some of the OpenAI officially published specification. And in this case, they're looking at the paths, and there's a path called files. And it has this little parameter in curly braces called file ID. And then inside of that, you have methods that are basically split by method. There's post, delete, all that normal stuff. And in this case, you just give it a unique name, which could be used to define a function, or in your documentation, you can tag it. So in this case, they're just tagging with Open API. But tagging is great for things like helping people search through your documentation. They can search by tag, or you can group things with the same tag together for display purposes. And then you include things like the parameters. So in this case, we saw this little curly brace thing up here, the file ID. It's described down here. So there's a parameter named file ID. Where did it come from? The path. Where else could it have come from? It could have come from the query string, the thing after the question mark, in a URL. It could have been like in a post body. So you can basically describe where the parameters come from, and this becomes part of the specification. So this is built on, I mentioned before, these JSON schemas, and JSON schemas allow you to just say, what should this look like? And it's a little bit different from the D programming language, because when you have data types in D, There are primitive types like integer and Boolean and whatnot. And then if you want more complex types, you can group them together with, let's say, a struct, or kind of a list of them using an array. It's a little bit different with the Open API spec, because the way it's done is it's a list of assertions that must be specified. So if I have two complex descriptions, it's not like multi-classing. It's more like both conditions must be satisfied. So it's almost like I'm like the intersection of these things. And so the types don't neatly translate into D. But some of the weirdness that you can express in JSON schemas is often not done in real life. In real life, most of the time, they have specifications that do fairly neatly translate into D structs, D classes, arrays, etc. So in this case, we have another example schema of using the reusable parts. So I mentioned components, for example. So when you're writing your specification, you can actually create data types that you can refer to. And in this particular case, we have one called create chat completion response. This is another example drawn from OpenAI. And what they're basically saying is, in order to specify this object, that's what they're saying here, type is object, it must have the following properties. So it has the properties ID, model, and choices. ID is a string, model is a string, choices is an array, and it's an array of objects. This word items is used to describe the contents of an array. And so over here on the right, we have an example of a data structure that satisfies the conditions on the left. It has the ID, which is a string. It has the model, which is a string. It has choices, which is an array of things, which are themselves objects, which have their own fields that are required. Index, message, finish, reason, as in this particular example. So it's very formulaic. It's kind of a one-to-one mapping of how this works, and which means it's great for code generation. Getting these specifications and turning them into D code that you can use as a client is not nearly as hard as you might otherwise think. So in terms, at the primitive level, at the base of these JSON schemas, there's two data types that are related. There's a type and a format. So in this previous example, we had types like string and a few other ones. You can have other types like integer and number, which have very much like JSON-like interpretations, but they're combined with this other thing called a format. And the format basically just bridges the gap, because in JavaScript, types are a little bit vague about what they mean, how many bits do they represent, and so the format narrows it down. Is this meant to represent a date? Is this meant to be a password? And things like this, like, well, password's not a special data format, what's the point? Well, the point is if you have tools that are automatically generated for like entering passwords or doing anything like that, it's a hint saying, oh, maybe you should hide this in UIs where users may enter a password, for example. So it just basically says, how do you interpret the raw data format? And you can define types in a very common way under this section called components. And the components lets you just make reusable pieces, like I mentioned before, common error codes, common request data structures, common response data structures. And inside of it, you can define common components which are grouped by either for schemas, for the response, parameters, request bodies, headers. Everything here is based on web request, and you're just breaking down the reusable data structures for that purpose. And how to actually make use of it. Once I define a reusable piece, what do? You basically are defining a reference to one of your data objects using this special format, which is defined as part of the official specs for JSON schemas. And you just have a special property called $ref, and then you refer to it by path. And this is essentially, how do I drill down into the JSON document to find this thing I defined? So the hash symbol just means the root of the document, and then you're basically going back down. The section where you keep reusable pieces, that's the field called components at the top of the schema. And then it could be things like, it could be reusable schemas, it could be requests, it could be parameters. So you just drill down the JSON schema until you get to the name of your piece, and that's how you use them. So then there's the other question. If you're developing a complex project, how do I manage these specifications and where do I generate them? Because there's a lot of different options for this. The two big pathways are when should I create the Open API specification? Should I start with my code and extract information from my code and turn that into the spec? or should I start from writing a specification and then generate code to interact with it? There's different people with different opinions, and there's no right answer. You just get different properties depending on what you chose to do. So this approach of generating a specification from code, it has some advantages. So it's very easy to keep it up to date. As you update your code, your compiled code that's been checked, the specification is always kept up to date. And you get a lot of support from language-specific tools. Like if you're using Java, there's a project called Spring Doc, which is doing a lot of this. And yeah, you can also go in the reverse direction and just generate code, and it has pros and cons as well. Now, in this direction, if we use our code to actually generate our specifications, it works great in very simple cases. I have my code. The code is used to generate the spec. The spec makes its way into customers' hands. All is simple and nice. But as your company grows and complexity grows, you start running into other problems. So let's suppose I'm actually introducing things like Python or D, and I actually have multiple projects that are working together to provide an interface for my customers. Well, if I happen to use a tool that was generating my specification from my Java code, how do I incorporate other projects? If there's no consistent tool chain that actually gets everything deployed to where it needs to go, changes are hard to keep up to date, and it can be a little bit tricky. Another approach is to turn things around a bit, is by starting with managing an open API spec and then have clients in your code be generated from that spec and then also publishing that spec to external players. This makes it easier for you to plug in projects that are in different languages, including D, and have them live in a coherent ecosystem with the rest of your services in your company or organization. Here's an example of why it can be a little bit tricky to generate specs from code, because all the information that's in the specification, if you're generating it from that code, that information has to live somewhere. This includes documentation, exceptions, use cases. This is an example of Java code where the API spec is actually buried in the code and extracted from these annotations. But as you can see, the code gets a little buried. It's kind of hard to see what you're working on when you do things in this way. And it can actually go back and have a negative impact on your productivity of writing your project because your project's code gets a little buried under these things. So in terms of writing something that works with OpenAPI and D, what's so good about D? What makes it useful to actually help generate code? And D is actually a wonderful language to generate code from just a very small number of features that you can reuse in novel ways. So one of the most common ways of doing is a mix-in. So mix-in just lets you take a string description of a piece of code and insert it as an actual code. It just gets embedded right in. Now you might think that, oh, it's a string. What if I have a typo or something like that? It is actually checked for syntax validity. So if you get something wrong, it will let you know right away. It looks a little ugly, but it is safe and it does work. Another feature that's very useful in D is, the times where you want to really use this is when you need to do something that affects the name of what you're working on. Like if I'm generating a function and I need to modify the name of the function based on a variable or create parameters, mix-ins are a great way of actually having very precise control over exactly what something is called because it's string manipulation. I can take a string in from the OpenAPI specification and make a function that has that exact same name without any trouble. Mix-in templates are similar in the sense that they're generating code, but the difference is you can take a block of statements that are parameterized like a template, and they get embedded right in the same place where they're called. They don't have a separate scope. The code gets inserted right away. And you can combine it with your previous use of mix-ins. So what we're doing in this particular case is we're just having this mix-in template called add field. And in this particular case, I'm adding it to, let's say, a class. And I know the type of the field, and I have the name of the field. So in this case, in this simple example, what I'm doing is I'm declaring the field to be a variable as a statement, and then I'm adding a setter function. And the setter function itself is actually a templated function. By itself, it seems kind of useless, but we'll use it again for something slightly more useful. So in this particular case, I have this class called fish, and I'm basically saying I would like to add two fields, a nullable field called age and a nullable field which is a string. And in this case, I can just have a fish, and I've not only have the data fields defined, but the two functions that were defined over here, the setters, are now available as well. So I can create a fish in a way that's kind of in a builder-like fashion. I have my fields defined, I can call my setters, and I'm good to go. Static for each is another feature that's extremely useful in D, and like the mix-in template, it embeds itself in the place you call it, but instead of just a single statement one at a time, for every single time that the loop iterates, it embeds that code directly in this context. The reason why this is so useful is you can do things like at compile time, what are the list of functions that I have in a class or a structure? What are the list of members? What are their types? And you can do objects, you can insert objects based on that. So in this particular case, instead of just adding the setters one at a time, I've made a dedicated mix-in template for this. So I'm iterating over all the fields of a class, and for each one, I'm calling the add setter function we defined before. So I just say, I want to add setters to a class. I want to declare my fields, and then I want the setter functions to be called automatically. And the setter functions themselves, all they basically do is set the field, and then I can actually return the class itself, so I can call it in using like a builder pattern. And of course, you can do things like not only look at my class fields, but I can also go up the inheritance chain. So if I have a class that inherits from another and from another, I can actually automatically generate a setter for every attribute, no matter where it is on the inheritance chain. And using it again, in this example, I have a class, I have something that inherits from it, I just say add my setters, and now I can create this builder-like pattern in one go. It just creates the code for me. And this is really great because if you have a textual description of the kinds of functions you need to create or usage patterns, instead of generating all the code again and again and writing it and maintaining it, you can just use a few compile time mix-in templates to generate large swaths of code to make your code much, much easier to deal with. So making use of these features, and given that I wanted to basically do Stripe processing and call other APIs, there's a project out there called Open API Client. And it's basically making use of these specifications to generate D code for you to use. So the way it basically works is you find some company that publishes an open API specification, some service you want to use. In this example, we're going to be using OpenAI. And you basically just run the project to generate the D client code, which is now callable by your application. And then you call the service that's out there in the real world. And that's kind of the goal, to keep it as simple as possible. So in this particular case, like step one is I want to get an open API specification. So in this case, OpenAI offers theirs available on GitHub. And so you can just download it. Theirs happens to be in YAML format, so we just convert it to JSON. And in this case, we just run the tool. We say, where is the file that is the basis of our API? And what is the root level module for your client? And that's it. The code is done. And so what does it produce? There's objects that are created, like request parameters, this kind of stuff, and the code ends up looking like this. It's based on Vibe. I know people have different opinions of different web clients they use, but these kinds of things aren't super hard to change. It's mostly, I need to make a call to someone out on the internet, so it's using the Vibe tools for that. So it has a mapping. This is basically for the JSON serialization. So this is very useful because sometimes an API will include a keyword, which is a D keyword, and you don't want to declare a variable with a conflict in the name. So it resolves that clash, but then keeps the name for serialization purposes. In this case, it's an optional field, so it uses the standard library nullable for that. And it produces just normal objects. These comments over here, this documentation, these are pulled straight from the Open API specification. So maybe you're writing some code, you're trying to get some code completion or just look at what comes next. You just pull out the documentation, you're good to go. So it works very friendly with a developer environment. The basic rules are, if it's optional according to the Open API specification, it becomes nullable. If it's an object that's kind of embedded and it can be used, it's a static inner class. All documentation from the spec is included in, and every object that you can create is you following a builder pattern, which we'll get to a bit later on how this makes it easier to call web requests. So in the second major thing that it could create are services. These basically map to groups of endpoints that I want to call. And they're usually broken down into, here's the name of the endpoint, which is pulled from the OpenAPI specification. In this case, it's an image edit. And you basically say, well, what are the parameters that I want for my request, and how am I going to deal with the response? And the deal with the responses, you can have many responses. You might get a HTTP code 200, which is successful, and it has one response. Or you might get an unauthorized error, like a 400 type error, and that has a different body. So the idea is you write a handler function, which is typed, and with the type coming from the OpenAPI specification, and you say, for each type of response, what should I do? So here's an example of the usage of it. So in this case, I have that, I want to call OpenAPI, and I have this create a completion service. So I want to know what's the cutest breed of rabbit, for example. You include in the request the model, saying what the name of the model that I'll be using, all your parameters, and this is just created in line. So I'm calling the create completion function, but I'm just building my request in place. And then I'm basically saying, how do I want to handle the responses? So in this case, I have the handler type, and this is what I want to do in if there's a 200 response code, but there could be other response codes, 400, 500, et cetera. You just fill in the logic for each one, and that's it. The usage is basically that simple. The response I get in this particular example is a little bit funny, and they talk about the different types of rabbit breeds and how there's many opinions about which breed of rabbit is the cutest, but the thing is, it works. That's the main purpose of this slide, is that you very quickly get a response that you can use. So future plans is that while it's nice to actually develop something that works and solves the problem, in the long run, you want something that covers every single corner case, and there are open projects out there like OpenAPI Generator, which has like a list of like 20 or 30 programming languages that it supports, and I would like to actually add D to that list. And yeah, the other option to consider is to go with the code first approach and maybe adding API integration annotations to something like Vibe, although truth be told, it's not my favorite approach. And that's basically the gist of it. So thank you for your interest and attention.
All right, last questions for the day. There we go, Attila.
Couldn't help but notice that when you're showing the specifications that it's basically a stringly typed API. For instance, at one point it has type string. So if you misspell that, oops. Wouldn't that suggest that it's better to start with the code and then generate the spec from it?
You mean the API itself?
Yeah, so in the specification, for instance, you had, this is an array, the items are objects. So if you misspell any of those things, it's going to be easy to make an error. And so the question is, doesn't that suggest that it would be better to start with real code and generate that instead of the other way around?
It depends on the problem you're facing. If you're working in a single language environment, you might find it more convenient to simply start with the code first. If you don't have to worry about anyone else. It really becomes more of an issue when you're working with different things. And often with D, you're the minority language. You're the new person to the party, and you want to say, hey guys, you don't have to stick to one language. You can work with D as well. And at that point, making the specification king gives you an opening for other languages like D as well. Also, when you run the tools to generate interfaces, you'll get an error then.
Anyone else? Come on, I know it's the end of the day, but somebody's got to have a question. Let's hear it. Oh, wow.
They want to hear about...
Oh, wait, there was one down there.
They want to hear about BeerConf.
Yeah, they're all waiting for BeerConf. I'm waiting for BeerConf, but I'm going to make sure people ask questions first. That's my job.
So when somebody like OpenAPI changes, or sorry,
AI.
Thanks. It's been a long day. So when OpenAI changes their API, they add a new endpoint or something like that, you're relying on the community to realize that and then regenerate the API?
Yeah, and normally this is pretty normal for companies because a lot of companies, they have people using handwritten clients. And so when they're modifying their APIs, they pay a lot of attention to make sure it's backwards compatible. So often, if they're going to have to make a big change to something, what they rather do is add a new endpoint, and then basically don't kill the old one until you can make sure that your user is no longer calling them. You got to give them proper notice periods, let them migrate. So the whole process, once you have a public service available, is quite deliberate.
All right, who's next? Come on, let's get one more question. Here we go. Timon's got one.
So I didn't quite catch how the built-in code generation tools that D provides are relevant for this project.
It's basically, it makes it simple. So because D is so good at basically allowing you to put together code, it's a mixture of just generating source files, but even the source files you generate can reuse bits of code for generating code. It's just less effort. So just one dude with a couple of hours, and you're good to go. It doesn't have to be a complex effort like it is in other languages.
Makes sense, thanks.
Oh, another question.
Thank you. So in the Java example you showed, it was basically the API is defined through all those annotations. I think I've seen similar things in Python as well, right? Where it's not really generating the spec document from the code, it's generating it from the annotations. Can you see a mechanism can you see a way in which you can lean, particularly in D, that you can lean more heavily on the code to generate the API spec? Or do you think you're also going to end up with a load of kind of annotation, pragma, pseudo comments in order to fill in some of this stuff?
The information you need when mapping to an API specification is quite a bit, because you have to handle like all the different data types, and the data types vary based on the response. Is an error response, is not an error response? And what makes it further complicated is the full power of the Open API specification doesn't cleanly map to a programming language either, because instead of having like clean inheritance with structs and class and whatever, it's just like a list of validation steps that have to be applied. So it could be a bit messy. You can do this though with D. You can do that approach, and it's very viable. But it would be very like framework specific. Because how do I specify answering an HTTP request? It'll be different in Vibe versus another web framework, and that work will have to be repeated for every type of framework that you have.
Yeah. Cool. I think we can call it there.
All right.
Yeah, good. All right. Thank you. And as I mentioned, that is the last of our talks for the day, which means we are wrapping up the first day of DConf 2023. What did you think? Yeah, programmer energy, come on. Yeah, I know, beer conf, we're all waiting for beer, but you know. So anyway, thank you for all the speakers for the day. Thank you for the staff so far for putting us up. And geez, I don't think there's much else we need to do for housekeeping here, Mike.
Nope, just the beer conf.
Well, let's get some food first so that we don't pass out after the first beer, hey?
Yeah. But tomorrow night, beer conf.
Yes, don't forget the Hrefs is going to sponsor the beers tomorrow night. So if you spend all your money on beer tonight, don't worry, you'll get some more tomorrow. It'll be all good. You're in London, come on. But otherwise, I'm going to call out everybody watching on the stream. I don't think we've had a single question from the stream, so do better tomorrow. And yeah, have a good one, everyone. See you here 9 a.m. tomorrow morning.